and then of course adding all of the new data sets now available for 2020. So this assessment represents an update and not a major reanalysis as we did last year. You'll recall that the stock assessment results for Pacific halibut are based on an ensemble of 4 different stock assessment models. And these models represent different ways over which we can aggregate the data that represent the strengths and weaknesses of different data sources in different ways. As we add different information to the stock assessment model, both trend and ages, each of these models has an alternative response. In some years, some models will go up slightly relative to the others. In some years, some will go down. But in aggregate, by using 4 separate models, we provide some additional stability from year to year as these individual models change. And what we can see over time is this provides us a more robust estimate of current stock status than we would get from any single model. And it avoids having to just choose a single model and ignore the rest. So these are the results from the 4 individual models from the 2020 stock assessment. And you can see that although the scale differs somewhat, they all agree that the stock went down substantially between the late 1990s and sometime around 2010 or 2011. And we had an increasing spawning biomass trend until sometime around 2016. And since that time, we've again seen a decrease in the spawning biomass, with some of the models being more pessimistic than others. If we aggregate these 4 models together and represent the entire stock assessment, here represented by the blue bands, with the blue line down the center being the median value from all 4 stock assessment models, you can see that we have considerable uncertainty about the peak of spawning biomass back in the early time period, but our uncertainty is much less in recent years as these models have converged and are giving us a much more similar picture of the recent trends. Now, imposed on top of this figure are also the results of the last 8 stock assessments. So starting in 2012 and going all the way up to last year's stock assessment in 2019, each assessment result is shown by a black line, and the red dot indicates the point estimate of the biomass at the end of that stock assessment. So again, this is as they were presented in each of those years. I presented these results, and this is now how they compare to this year's stock assessment. And you can see that although the scale has differed a little bit up and down year to year, overall, the general trend has been very similar. In that time period from 2012 to 2016, we were estimating every year that the stock was increasing slightly. And then subsequently that the stock has been going down since then at about the same rate as it was going up since 2010. And so what we see is a lot of consistency in the results of the stock assessments over the last 8 years and now 9, including the 2020 stock assessment. If we look at the individual recruitment estimates from each of these 4 stock assessment models, each here shown in a different color with the vertical bars representing the uncertainty around each of them, you can see a considerable difference in scale of recruits, and that has to do with the estimates of natural mortality that come out of each of these different models. Models with high natural mortality tend to estimate much larger absolute number of recruits moving into the stock. But what's important here is not so much the scale, because that gets factored out as these models project forward ultimately into the spawning biomass. What's particularly important here is the pattern among the 4 series. And you can see up until about 2010, all of these series are quite parallel, meaning that they all indicate strong year classes in about the same years. 1999 and 2005 were the 2 strongest year classes that are still extant in the current fishery. Then we had a time period from 2006 to 2010 of estimated low recruitment. And now we have the 2011 and 12 year classes coming in. And you'll note that that is where these models start to diverge from being fairly parallel across that time series. And what that indicates is that each model is responding slightly differently to the incoming data on these year classes. And it won't be for several more years until we get a more precise read on just how strong these year classes are relative to 2005, 1999, and earlier strong recruits. I would note that if 1987 were included in this figure, and we don't have estimates of that year class for the youngest ages for all these models, that year class would be much larger than anything you see in this graph. The other point I'd like to make on this figure is the lag time between what we see in the setline survey and what we see in the fishery and then ultimately in the spawning biomass. So as I showed you earlier in this presentation, the 2020 fishery was just reaching out to the point where we're starting to see the 2012 year class moving into the fishery landings. The setline survey, however, has been seeing those 2 year classes for approximately 3 years now. Notably, though, seeing them in greater abundance each year as they move their way into the stock. Finally, if we think forward to the spawning biomass, these fish are roughly 50% mature at age 11. And so the spawning biomass is comprised mainly of fish that were born in 2009 and earlier. What this means is that we're going to see a lag as these year classes, 2011 and 12, become more important to both the fishery and to our survey trends. It's still going to be 2 to 4 more years until they start to contribute appreciably to the spawning biomass. And so we can expect that our projections are going to lag somewhat behind the trends that we see in the individual areas because those fish take a little bit longer to graduate into the spawning biomass than they do to enter the survey and the fishery. This next figure shows the results from this year's stock assessment with regard to fishing intensity. And these are all calculated relative to the current F43 reference level. I've also highlighted in this figure the F46 reference level that was applicable from 2016 to 2010. And you'll note that we had a period of relatively high fishing intensity in the early 2000s that dropped substantially until around 2014 as a function of very large reductions in the mortality limits that were being set in that time period. And then 2014 to 2019, we've had slowly decreasing fishing intensity as the limits have been adjusted and somewhat reduced over that time period, but still slightly on average above the F46 reference level that was applicable during that time period. I note that in 2020, as I highlighted in the first few slides of this presentation, due to the reduced mortality limits, and in addition, due to the fact that many sectors did not reach their full limit, we actually ended up at a lower estimate of fishing intensity of an F48% for 2020. So somewhat lower than we had projected at last year's annual meeting. Move now into the calculation of relative spawning biomass. So I've shown you absolute spawning biomass. The relative spawning biomass estimates the effect of fishing on the spawning biomass. So it estimates what fraction of the unfished condition would we have in each year after we have exerted fishing mortality on the stock. And so the blue line shows you our best estimate from the time series. The blue band, the shaded band, shows you the uncertainty interval associated with that, and it is considerable, especially in some of the earlier years where we're not sure exactly what the scale of the stock was. The red dashed line shows the trigger reference point of SB 30%, below which if we estimated in a particular year that the stock had dropped below that SB 30% level, the interim management procedure would suggest a reduction in fishing intensity linearly down to the limit reference point at SB 20%, which is that full red line across the bottom, and the shaded zone at the bottom represents the area of conservation concern. If the stock were to dip below that SB 20% level, we would consider that to be a conservation concern. And you would interpret that to be the effect of fishing has then reduced the stock by at least 80% from where it would have been if we hadn't been fishing on the stock. So you can see, looking at this time period, that somewhere around 2012 or 13, fishing had had its largest effect on the stock. We had reduced the stock to the greatest amount due to the fishing mortality being exerted on it. Since that time, with the reduction in fishing intensity, we've seen a slight recovery. And at the beginning of 2021, we estimate the stock to be at 33% of that unfished condition. This next table shows you a summary of several different values from the stock assessment. A few things that I'll call out. One is that the utilization rate, or the fraction of the overall mortality that was retained, has gone up somewhat, mainly as a function of decreases in non-directed fishery discards, as well as discards in the directed fishery. So we're now at approximately 84% utilization rate, which is somewhat better than we've done in the last few years. As I've already noted, that mortality trend has been decreasing, and the fishing intensity estimates have also been decreasing. The spawning biomass has now decreased approximately 17% from 2016 to 2021. So that slow decrease, it continues for another year. Finally, I will note that although we have a reference level of fishing intensity, which is now at F43% for 2021 and moving forward, that the limit reference point or limit level of fishing intensity has not yet been specified in our harvest strategy policy. So the modeling highlights from this year are that although we see these 2011 and 12 year classes clearly in the data, we don't yet know how strong they are. And unfortunately, it takes several years of fishing on these year classes for us to get a strong estimate of just how large they are. I would expect over the next several years, now that they have graduated into the directed commercial fishery, we'll get a much stronger read on just how large the magnitude of these year classes is. And part of that is because even though we see them strongly in the age composition data, we don't see a strong response in the numbers per unit effort. And so that suggests some ambiguity about just how large these year classes are. Finally, as I've noted several times now, the reductions in mortality in 2020 have led to somewhat lower levels of fishing intensity. So that would be our silver lining for 2020, is that we ended up with an easier year on the stock in terms of fishing intensity. Now I'll move into the projections and then into the decision table. So we make these projections each year, and we use a constant TCEY, recognizing fully that the Commission will be back next year to make another decision. By providing a constant TCEY for 3 years, it allows us to see the effect of that a little bit more clearly than if we only made a one-year stock projection. Secondly, we provide in the projections a range of mortality, from no fishing mortality at all in order to evaluate the stock dynamics, up to a large level. In recent years, we've used a value of 60 million pounds to describe what would be considered a high level of fishing intensity. We also provide additional detail between F40 and F46%, and I'll highlight a few of these columns or these specific levels as they relate to recent years and other reference points. So to give you a visual on these projections, this would be the stock projection of spawning biomass in the absence of any fishing mortality over the next 3 years, and this would include all fisheries from all sources. And you can see that based on the current growth rates for Pacific halibut, about the best we could do would be to get back somewhere near where we were in 2016 over the next 3 years. And this is a good reminder that halibut dynamics move relatively slowly. We see fairly long-term changes, and even drastic management changes may take some number of years to have much of an effect, as we see in this figure. The next level of projection that I'll show you is what I'll call the 3-year surplus production, or the break-even level. And so this is the TCEY for the next 3 years that has a 50-50 chance of leaving us right where we started at the end of 3 years. And that value is 24.4 million pounds. So substantially below the TCEYs in the last few years, but slightly above what we had estimated from last year's stock assessment as a function of these year classes moving into the stock. The next projection is the status quo. So this is the coast-wide TCEY of 36.6 million pounds from 2020, projected forward to 2021, 22, and 23. And you see at the status quo level, we would expect continued decline in the spawning biomass at more or less the same rate that we've seen over the last 4 years. Next, we have the projection at the reference level of 39 million pounds. And this is the TCEY that we estimate to correspond with a projection of fishing intensity of F43%. And so at that level of 39 million pounds, if repeated for 3 years, we would again expect to see just a slightly more steep decline than at the status quo, recognizing it's a couple million pounds higher, but still not a dramatic difference in the stock trend. And that's going to lead to similar probabilities in the decision table moving forward for these two different catch levels. And finally, the last projection at 60 million pounds, considerably above any level of mortality we've seen in the last several years, you can see quite clearly that the effect of fishing is starting to have a much larger effect on the spawning biomass, that you see a much steeper decline in the spawning biomass, steepening even from what we've seen over the last several years. So we definitely see a much stronger response to fishing as we start to greatly exceed the level of surplus production in the stock. Okay, that brings me now into the decision table. And the decision table, as we've done for several years now, it provides a risk-benefit analysis. It provides an evaluation of the trade-offs between potential yield and risks to the stock and the fishery. We calculate this decision table relative to the interim management procedure. And this is important because for the probability, for example, of further decreases in the fishery, we have to calculate that relative to some projected level of fishing intensity. And so we're using now the F43 level of fishing intensity as adopted by the Commission for 2021. So these are the headers from the decision table, and I'll begin by introducing the structure of this table, and then I'll show you the contents. So the headers report first across the top an identifier for particularly important columns in the table. Each column represents a level of yield moving into 2021. The top row shows the total mortality, the second row the TCEY, and the third row the level of fishing intensity that we estimate to be associated with that. However, you'll note that there's a broad interval in the level of fishing intensity reported in the fourth row down, which indicates the uncertainty about the actual fishing intensity that would be associated with a fixed TCEY. Once we pick a TCEY, then the level of fishing intensity is uncertain until we estimate it subsequently. So the way this table is divided up, we have, moving from the left to the right, we have increasing levels of harvest and fishing intensity, ranging from no fishing mortality to the break-even level, or that surplus production level that I showed you in the graphical projections. Then we have a block across the center, which provides a finer resolution between F46 and F40%. This is a range of levels of fishing intensity that have been identified through the MSE process as all being in or around meeting the objectives for both the fishery and the stock at a coast-wide level. So this has been the primary area of consideration for the MSE process as they've moved forward. And so we provide additional resolution here in approximately 1% increments from an F46 down to an F40. Within that, you'll see several things fall out. On the far left is the F46% level, and that would have been, up until last year, the reference level at F46%. Following that, at F45%, is the status quo level of 36.6 million pounds, or last year's TCEYs. In the center of this block is the reference level of F43%, which for 2021 corresponds to a 39 million pound TCEY, and then increasing to the right. Finally, on the right-hand panel, for contrast with these other alternatives, we have a 60 million pound TCEY, as I've shown you in the graphical projections. So with this range, we can now then compare these different alternatives across different risks to the stock and the fishery. So the first block that I'll show you is the stock trend. And the way you read each row is, what is the probability that the stock trend in 2022, in the top row, is less than 2021? That's the first row across this table. And you'll see that across this range from F46 to F40, we have roughly a 2/3 chance of further stock decline. And that's what we saw in the figures of the projections that I just showed you, is that there's a relatively high probability that anywhere in this range, we're going to continue to see further stock decline. And this is a function of those weak recruitments we had from 2006 to 10 as they move through the stock across even a broad range of fishing intensities, we're going to see continued stock decline. Now, we'll note that in previous year's tables, we sometimes saw more contrast in these alternatives, and that's due to two things. One, it's due to the buffering of these year classes coming in the later years, starting to mature in 2023 and 2024. In addition, it's also due to the fact that we've now narrowed this band down, where in previous years, sometimes we had values ranging from F35 all the way to F50 something. Now we've narrowed this central band down to an F40 to an F46% range. So that's partly why we see less contrast in this year's table. Again, the 3-year surplus is defined by the fact that it has a 50% chance of having lower biomass in 2024, 3 years out, than it does at the beginning of 2021. So that is the definition of that row. Moving then into stock status, this section now poses the question, what is the probability of dropping below our reference points, either the trigger at SB 30% in the first row, or the limit reference point of SB 20% in the second row, and then each of those is repeated for each of the 3 years into the future. And I'll call your attention all the way across to the F40% level, where even at an F40% level of fishing intensity, we estimate less than a 50-50 chance of dropping below SB 30% in the next 3 years. Further, the second, fourth, and sixth rows down indicate that our probability of dropping below an SB 20% level remains below 12% or at or below 12% across all of these alternatives in the central part of the table. So we have a modest to reasonable chance of dropping below SB 30%, but a fairly low chance of dropping below the SB 20% level over the next 3 years. Finally, the last two sections of the decision table report the fishery trend and status metrics. The upper section, you would interpret that section by posing the question, what is the probability that if we took a TCEY of one of these values, that we would have to then take a cut in the fishery to get back on an F43% policy in the future? And so the center of the decision table and the top row is exactly 50%. Because that's the definition of the reference level. It's the level at which we would stay right on that F43% in 2021. You note that there's not a lot of contrast across this whole section of the table, indicating that across this range from approximately 43 downwards to 35.5 million pounds, there's roughly a 50-50 chance that we'll have to take additional cuts in the fishery to get back to the reference level at some point in the future, either 1, 2, or 3 years out. Okay, so those are the coast-wide results and a prognosis of where we see the stock going over the next several years. Now we can start to break that down with a little bit more detail into projections for regions and individual IPHC regulatory areas. So for 2021, we have created a revision to the mortality projection tool as it's been available for the last several years. This tool is intended to provide for the evaluation of alternative scale and distribution of mortality. So you can change the total and change how it's distributed across the coast. As we noted last year, the interim management procedure has become complex enough that this tool was relatively challenging to use last year in implementing all of the agreements that were currently in place and then further evaluating other alternatives. So we've made some modifications to that tool, and now all parts of the current management procedure, interim management procedure, are included in the tool, and so hopefully it will be easier to use this year. Noting that this tool is not yet available, we'll be posting this after we receive the post-season 2020 mortality estimates so that we have the final values for use during the lead up to and during the annual meeting 097. However, even though the tool itself is not yet available, I'll direct your attention to informational paper 3, which provides not only more information about the tool and its outputs, but also more detail about how the interim management procedure is calculated. What are the steps taken to do that? And that's what I'm going to spend a second now on, is describing the various steps that are included in the interim management procedure. So the interim management procedure, which the Commission has directed should stay in place for 2021 and 2022, is based on a number of different inputs. And I've divided these into two parts. First is the baseline, and the second are adjustments to that baseline. Now the baseline is a reference fishing intensity level of F43%, a 30-20 control rule, whereby that reference level of fishing intensity is reduced if the stock goes below 30%, the O32 stock distribution as estimated from the space-time model, and relative harvest rates of 1.0 and 0.75. And I'll note that all of these components, with the exception of the F43%, are consistent with previous management procedures all the way back to the blue line. So the 30-20, O32, and relative harvest rates have been consistent right through this process over the last approximately 8 years. The F43% is a revision to the reference level that was adopted in 2020 from F46 in previous years. Now the adjustments to that baseline are in two parts. The first part is IPHC Regulatory Area 2A is assigned a TCEY of 1.56 million pounds. And the percent of the coastwide TCEY in IPHC Regulatory Area 2B is based on a weighted formula of 70%, of 20%, and 30% of the baseline as calculated above. Finally, there's an additional adjustment for IPHC Regulatory Area 2B, which is to use that formula and then add on the difference from the 2B TCEY with and without accounting for U26 non-directed discard mortality. So essentially, if we take all the U26 discard mortality out, all the TCEYs go up, and half of that difference for 2B's TCEY gets added back on and retained in the final interim management procedure. So what I've just laid out is exactly the way the mortality limits, the reference mortality limits were calculated for the 2020 fishing season, with the exception of the F43 level of fishing intensity. So I realize that's a lot of information. I'll step through the calculations, and hopefully it will make more sense as I step through the various calculations. So in this first slide, what I'm showing you is the estimates of O32 stock distribution across the top. Second is the relative harvest rates applied to each of the IPHC regulatory areas. And the combination of those two results in a TCEY distribution. You'll note that that distribution is slightly higher in the eastern areas and slightly lower in the western areas as a function of the application of those relative harvest rates. As an example, IPHC regulatory area 3A goes from 36% up to 40% as it gets a full 1.0 relative harvest rate relative to 0.75 in the western areas. Now, after the TCEY distribution has been calculated, then we can move to the adjustments. So the first set of adjustments is to assign to A a TCEY of 1.65, and then to use the weighted formula for 2B, which results in, for 2021, in an estimate of 17.5% of the TCEY in 2B. We don't have the other values yet because we need to know what the total TCEY is. And so we calculate the total TCEY based on the reference level of F43%. So from that calculation, we find that the total TCEY is 39 million pounds. And then once we have that value, now we can apply the 1.65 to calculate the percentage for 2A and the percentage for 2B to calculate a TCEY. Noting in 2B that that percentage then is adjusted to account for, in this case, for 2021, 0.18 million pound addition to account for U-26 non-directed discards in Alaska. The rest of the IPHC regulatory areas are held in exact proportion to the third row up, or third row down in this table, and are adjusted accordingly until the entire distribution sums to 100%. And that's what provides us with the interim management procedures, TCEYs distributed to individual IPHC regulatory areas across the bottom of this table. Now I'll put those in context by comparing them to recent calculations, first of the reference TCEYs and also the adopted TCEYs. And I'll do this first by region because it's a little bit easier to see some of the broad trends. I noted early in this presentation that we saw a fairly big decrease in catch rates in region 2, which corresponded to a decrease in our estimates of stock distribution, and a corresponding increase in region 3. Well, you can see that quite clearly here, where the reference level from 2020 to 2021 has gone up substantially from 31.9 to 39, but the increase in region 2 is much smaller than the increase in region 3, where region 2 is adding approximately 1.4 million pounds. It's much larger in region 3. You can also compare to the aggregate of the adopted TCEYs in each of these IPHC regulatory areas, noting that particularly in those years in 2018 and 2020, when the reference TCEY was low, the adopted TCEYs tended to be somewhat higher. Finally, I'll break these down all the way to the level of individual IPHC regulatory areas. And here you can now see quite clearly the effect of some of the specific trends in stock distribution that occurred in 2020. So I'll draw your attention to the fourth column in IPHC regulatory area 3A, where the reference level went from 9.8 million pounds last year up to 14.11 million pounds for 2021. And although all the areas went up from their reference level, that's the single largest jump, and that's due to that 24% increase in O32 weight per unit effort that was observed from 2019 to 2020 for IPHC area, regulatory area 3A. I'll also note that while all of the reference TCEYs did go up or stay the same in the case of 2A, where it's fixed at 1.65, while they all went up from 2020 to 2021, that doesn't necessarily correspond to an increase from the adopted TCEY that you see in the bottom row of this graph. In those cases where the adopted TCEY in 2020 was above the reference level, particularly in 2C, it does not correspond to an increase at the reference level for 2021. Finally, then using preliminary values in the mortality projection tool, we can then provide, and again, this is preliminary, we'll be updating the non-directed discard estimates at the end of the year in time for the annual meeting. The preliminary breakdown of these, just to get a sense of what these various TCEYs might mean to individual fisheries sectors in the different IPHC regulatory areas. Noting that it's probably best to focus on the detailed breakdown for your own regulatory area if you have one that you're familiar with, because the catch sharing plans or the catch agreements in each of these areas differs quite appreciably. And that's why you see components that are listed both in and out of the FCEY. That has to do with the specific wording in the catch agreements. But if you sum all of those up, the TCEYs all include comparable components throughout all of those areas. And the only component that's not included in the TCEY is the non-directed discard mortality of U26 Pacific halibut, which is the second to last row there. And then at the bottom, at a reference level of 39 million pounds, we would estimate that that corresponds to just over 40 million pounds of total mortality projecting forward into 2021. And that concludes my presentation of the stock assessment and projections for 2021.
Thanks very much, Dr. Stewart. Are there questions? Peter.
Thanks for that presentation. Really well done again, Dr. Stewart. Hoping to look at slide 11. I have it on here. I think it would be helpful if we see the slide. Yeah, so I'm just looking at particular for 3A. And I was trying to understand something. Do you see 3A as more of a correction for whatever reason, rather than a general trend in terms of this increase? Or do you see that as a trend?
Through the chair, thank you, Commissioner DeGreef. I think there are probably multiple components that are going into what we see realized in the setline survey each year. Certainly, even a survey as extensive as the IPHC survey with almost 1,900 stations in the full design is still a relatively blunt tool to sample the population. We should expect to have some year-to-year variability due to a myriad of factors that influence our catch rates. So that certainly sampling variability could be a component. However, I also note that during the same time period, we've seen apparently some shifts in the distribution of these incoming year classes. And so I think that that's probably also contributing to this. In 2019, we quite clearly did not see a large representation of the 2011 and 12 year classes across the center of the stock. And they were starting to show up a bit in some of the other regulatory areas. Now in 2020, we're seeing them across most of the regulatory areas. So I think it's probably a combination of both of those factors.
Okay, and just a follow up on that. If it's not specifically and strictly a trend, how would you see that affecting areas that weren't surveyed? So if we're projecting there's a general trend, would that somehow influence the understanding in areas that aren't surveyed?
Thank you again through the chair. It's a good question, and we only have the data available to us from those areas that were surveyed. In the areas that were not surveyed, we're essentially relying on the recent trend and the temporal correlation with previous catch rates in those areas. Unfortunately, because of the design in 2020, we're not even drawing information from adjacent areas because we didn't have sampling at the extreme southern end of 2B, and we didn't have sampling in the western side of 3B. And so 2A and 4A are essentially uninformed by nearby areas. That said, we don't see large changes projected for any of those areas. However, what happens in these models when in the absence of data is that they're informed by the previous catch rates and the covariates that are in those models, accounting for depth and other factors. And so I think that in the end, we would see these models slowly heading back toward their long-term mean in the absence of new data. Now, because of the additional uncertainty, that's not going to have a strong effect on stock assessment results, but it could have an effect on stock distribution, and it's certainly an uncertainty to be aware of. You'll note, particularly for IPHC regulatory area 2A, that the interval on this plot in the upper left-hand panel there is much wider in 2020 than it has been since probably the early 2000s, when we did have some concern about the level of uncertainty there. And that is the cost of not being able to sample that area in 2020.
Okay, thank you for that.
Richard.
I got a couple questions. Thank you, Ian, as usual, for a great presentation. Back on the slide, around slide 14, you start going through fishery trends. And I'm just curious, what's the relationship between these charts, fishery trend, and the stock assessment? Is this just an observation, or is there any kind of connection between the two, the fisheries trends in these charts and the stock assessment?
Thank you, Commissioner. Yes, it's a good clarification. So I provide the trends both from the FIS survey and from the fishery because these are both used as indices of abundance within the stock assessment. So they're both informing the trends that we estimate. And you'll note that this coastwide trend from highs in the late 1990s down to about 2010 and relatively flat, that's actually pretty consistent with the trends that we see from the stock assessment. However, I will note that because the fishery is not standardized the way the FIS survey is, we have to allow for more flexibility. We allow for catchability, or the amount of catch per effort, to change over time in the fishery. And we also allow for changes in selectivity as the fishery moves around, targets different demographics, and overall the catch gets allocated to different regulatory areas. So we don't draw as much information from the commercial fishery, but both of these sources are definitely included in the stock assessment.
Second question goes back to probably slide 18 and 24, where you talk about size of age. And I was just wondering, has there been any discussions about recalibrating the IPHC halibut size to length tables? I mean, that's a very important table that the fisheries use to calculate a lot of the weight estimates. And with this fluctuation in size of age, and I assume that this data is being updated every year, but from the surveys, is there any studies relating to some kind of calibration of this, both in terms of coastwide and possibly regionally?
Thank you, Commissioner. Through the chair, yes, in fact, this is an area of active research for the Commission. As you'll recall, we began in 2015 collecting individual halibut weights in the ports as part of our standard port sampling, and we've continued that. So since 2015, we've not had to rely on the standard length weight equation for the directed commercial fishery. Beginning in 2019, we also added collection of individual weights to the FIS survey. And so both 2019 and 2020 weight per unit effort is based on measured weights rather than predicted weights from the length weight relationship. And I think those are very, very much going to strengthen our data sets moving forward. Now, however, we still do use the length weight relationship to describe many other data sets, including non-directed discards and recreational sectors. And we recognize that there has been some observed deviation from the length weight relationship, particularly in recent years. And so it is an ongoing effort to revise that. We have waited to do that revision until we had at least a couple of years of fish survey data, so that we had those length-weight relationships informed not only by the larger fish that we see in the commercial fishery, but also by the smaller fish that we measure on the fish survey. And so I would anticipate that very soon we'll be able to revise those. And we don't yet know whether the variability is such that we will need to have a length-weight relationship that maybe changes over time, or perhaps doesn't change over time, but recognizes some of the differences that seem to persist among IPHC regulatory areas. So both of those two things are possible, and I would anticipate some revision to the length-weight relationship in the near future.
Neil.
Thank you, Dr. Stewart. I had a question about the portion of your presentation where we were talking about recruitment. I think it was in relation to the PDO, although my question isn't really about the well, it's partly about the PDO. When we use the term recruitment, are you thinking of a certain age range within the stock that is positively or negatively influenced by the PDO? Or is it the entirety of the stock that is responsive to those conditions? I guess a bit of a two-part question there. Thanks.
Commissioner Davis, yes. In fact, recruitment is a term that's used quite differently across many different fisheries analyses. In some cases, it's used to refer to the time when fish actually recruit into the fishery. In the case of the Pacific Decadal Oscillation and the link there, we are noting the correlation between age 0 recruits. So essentially, fish that are born and subsequently then move into the stock. So that we expect that the relationship between the Pacific Decadal Oscillation and incoming recruitment is somehow a function of either the egg or the larval or the early juvenile stage, noting that we don't really observe these fish until about age 2. So everything below that essentially gets swept up together into our understanding.
Did you have other questions, Neil?
No, that was my main question. I guess do we know that whether the PDO has any association with the positivity of conditions for the rest of the stock?
Thank you, Commissioner Davis. Our understanding of recruitment is not great. We see these large year classes coming in some years after they're actually born, but based on surveys up and down the coast with a variety of different gears, we understand that the bulk of the young Pacific halibut, and I'll call early juveniles that time period from 0 to 2 years old, and these are fish that have settled out into shallow nearshore areas. We understand that the bulk of that comes from west of Kodiak Island in the Gulf of Alaska and around into the Bering Sea, and that those fish then over their lifetime are moving back down across a wide range of the stock. And so in that regard, the conditions in the Gulf of Alaska in the areas that are most likely for spawning to contribute to those Western Gulf areas are probably the most relevant. Not to say that conditions in the rest of the stock aren't important, but given that the core of the stock and likely the core of the spawning occurs in the central Gulf of Alaska, I think this is probably the most important place to focus our attention.
All right, I'm not seeing any further questions, Dr. Stewart. I think we can move on to the next agenda item on the size limit review.
Thank you, Mr. Chair. I'll just hold tight while the support crew queue up the next presentation. And I will note for everybody's benefit that this one is much shorter than the one I've just completed. Perfect. Thank you, and hello again. I'm now going to present to you a brief overview of an evaluation of the directed commercial fishery size limits for 2020. This is in direct response to a request from the Commission at the annual meeting 096 last winter. So we phrased this exercise as, what if we had not had a size limit in 2020 when we set the catch limits? So let me give you a quick summary, and then I'll go through some of the details about the analysis. If we had not had a minimum size limit in 2020, we could have potentially increased the yield to the fishery by 7%. That's 7% more pounds across the dock. We would expect that that would correspond to an increase in fishery efficiency of 18%. Fishery efficiency being the amount of catch handled per landings brought to the dock, and a decrease in discard mortality of around 800,000 pounds. It turns out it was slightly lower than that in 2020, but that was our estimate at the time. Further, and this is one of the main questions that's arisen in previous size limit analyses, or what would have happened to the value of the fishery? And so we introduce a new metric here of critical price ratio, suggesting that if the price paid for these U32 fish were at least 60% of the price for O32 fish, then the fishery would have gained value, perhaps a lot of value if that percentage had been higher than that. But that provides a metric of the break-even point. And finally, we note that the imposition of size limits would have a substantially different effect across different regulatory areas. And I'll go through each of these things in much more detail here in a second. We also evaluated what would have been the case had we added a maximum size limit of 60 inches for 2020. We found that that would be approximately yield and value neutral, so it would have shifted things around a little, but no real gain in yield or value. It would have increased the discard mortality by a little over 100,000 pounds and a small decrease in fishery efficiency. It would tend to increase the spawning biomass of those largest fish and therefore encounter rates in recreational and other fisheries. We don't believe that this imposition of a maximum size limit would change net recruitment. However, it would also have a substantially different effect across IPHC regulatory areas. So that's the summary. Now let me go into some more detail. And I don't have time today to take you through every step of the paper. I'll note that there's quite a bit of analysis, and in fact, appendices describing in more detail the methods and some additional data sources, such as a detailed breakdown of fish below 32 inches from the FIS survey in one of the appendices. But overall, the document provides a background, a summary of the historical studies on minimum size limits, a summary of the data that we have, both for the minimum and a potential maximum size limit, and then an evaluation of each. As I've noted, the evaluation is done as a replay of the catch limits in 2020, what they would have looked like with and without these size limits. So to recap the historical studies, and again, there's a much more thorough discussion in the paper, but in a nutshell, these historical studies have shown that we've increased our foregone yield over time. So early on, the first few size limit analyses, and I should say that a great number of people have evaluated the size limits. Beginning in the year that the size limits were implemented, the Commission almost every 3 to 8 years has had another size limit analysis throughout that entire time period, trying to better understand what are the effects on the stock and the fishery. Over that time period, each of those analyses has subsequently estimated a slightly larger amount of foregone yield. And I think that this most closely tracks the decline in size at age, where early in the time period, just after the size limits were put in, the fish were still growing very rapidly. And now, decades later, with much lower size at age, the potential benefits and perhaps even costs of a size limit have changed dramatically. There's also been an increasing recognition over time that discards and discard mortality rates matter. So the early studies didn't really consider the effect of discards and discard mortality, whereas after several of those studies, and these are all referenced in the paper, there was an increasing acknowledgement that actually the success of a minimum size limit depends on discard mortality rates. At very high discard mortality rates, in the extreme, at 100% discard mortality rate, it doesn't make sense to have a minimum size limit under any conditions because they're all ending up dead anyway. So that's also been a change over these historical studies. And finally, In the early years, these studies were evaluating size limits in the context of a management system that did not respond directly to mortality of young fish. So this was essentially in the early years providing a buffer against catch limits that were being dealt with just for larger fish. Now, based on the shift to SPR-based management in 2017, the Commission is actively managing to maintain adequate spawning potential regardless of how the catch is distributed. So there's no additional benefit to the management system of having a minimum size limit, given that we're already accounting for the effect of mortality regardless of which demographic it comes from. So by way of background, and just to sum up some of the data that's available, the U32 discard mortality, and these estimates are only through 2019. When we first prepared this document, we didn't have the 2020 final estimates available yet. But this provides you with a look back over 3, 5, and 10 years from 2019. And you can see that at the 5-year average, discard mortality in the directed commercial fishery, and this is directed commercial fishery only, has comprised approximately 1 million pounds a year. So there's 1 million pounds of halibut that end up dead and not utilized. As a percent of the total commercial catch by weight, this corresponds to somewhere in the range of 4% at the 5-year average. Noting that it varies pretty substantially with the low overall of 2% in IPHC regulatory area 2C at the 5-year average and a high of 7% in regulatory area 3B. And these correspond to the two areas with the lowest and the highest encounter rates of sublegal fish in their fisheries. So how about large fish? What data do we have available for large fish? Well, we looked both at the setline survey as well as in the commercial fishery data for the last several years. And because we now have sex-specific commercial fishery information, we can look at this directly in the context of the commercial fishery. And I don't expect you to be able to read all of this table. This is an abridged version of Table 4 in the document. But what I would call your attention to here is that of these fish, and we evaluated 3 potential levels here, 55, 60, and 65 inches, basically all of these fish are going to be females. There's no question that once you get above 55 inches, most Pacific halibut that are that size or greater are females. However, one thing that we would normally expect is that if we protected large fish, we would be protecting the old fish and therefore likely the mature fish. Is not necessarily the case. So I'll highlight here in the center of the slide the average age and the age range for IPHC regulatory area 2C. And you'll note that although the average age of a fish that's 55, 60, and 65 inches is around 17 or 18 years old, there are also some fairly young fish included in there. So the age range at 60 inches ranges from 9 to 36 years old. So that is, fish above 60 inches in IPHC regulatory area 2C may or may not be older than 10 years old, and they may or may not even be mature yet. And so unlike some settings where you have some fisheries where you have a very direct translation from size to age, we don't see that for Pacific halibut. So protecting large halibut is going to actually capture or is going to actually influence a wide range of different ages. And that's going to vary somewhat by regulatory area as well. So this figure here, and I realize you can't read the axes. The x-axis is age going across the bottom, and it's proportion of the catch on the y-axis. And this just shows you the distribution of fish that are greater than 60 inches by individual IPHC regulatory area. And you don't even need to be able to read the labels to see that if I put age 16 in there, age 16 being one of the older ages that's still relatively common in the fishery, you can see in the top right, IPHC regulatory area 2B, a substantial fraction of those 60-inch fish are actually below age 16, quite a few of them. And similarly, 2C, which is the second down on the left, again, a large fraction of those fish are actually less than 16 years old. Contrast to 4B in the bottom left, where almost all of those fish that have reached that size are older than 16 years old. And so the biological effects, as well as the encounter rates in various fisheries, are going to differ quite substantially by individual IPHC regulatory area. Okay, so what did we do with these data, these inputs? As I mentioned, we did a replay of the 2020 mortality limits. And so the process went like this. We had the 2020 mortality limits as they had been adopted. And what we did was to remove and add the size limits. We also accounted for several sensitivities whereby maybe the fishery would target on small fish, or maybe they would actively avoid small fish. We don't actually know. So we allowed for several sensitivity analyses to see how much difference that would make. And then importantly, what we did was to match the same SPR, or level of fishing intensity. So we said, okay, here's the level of fishing intensity that was adopted. Let's make sure that doesn't change, and then recalculate the yield, discards, and all these other metrics from the fishery, both with and without size limits, but importantly, maintaining that same level of fishing intensity. So what that means is that the reproductive output per fish is held constant across all of these different alternatives. And so what we can see is at the same level of fishing intensity, how does this play out in terms of fishery yield, discards, and other metrics? And so the results can really all be summarized in a single figure. What this figure shows you is for each of these different alternatives, the amount of relative yield that was produced by that alternative. So on the far left-hand side there, you see current minimum size limit, and the yield is 100%. So that was the adopted catch limits. Then you see across the middle are a whole range of different alternatives showing having no minimum size limit in 2020 and having different levels of targeting or avoidance, ranging from 30% avoidance on the left up to 30% targeting on the right. And so the green and the blue illustrate the fraction of the yield that would come from fish that are less than 32 inches. So clearly you can see those green bars are increasing as you move from left to right. The yield is actually increasing as well. So if there were some targeting of U32 fish, it would actually serve to increase the yield to the fishery under this current level of size at age that we're seeing in the stock. Not dramatically, but by as much as 6 to 8% across this range of different fishery responses. On the right-hand side is the maximum size limit. And you can see that at a 60-inch maximum size limit, the yield is estimated to be approximately 100%. So essentially no change in the yield available, even though that yield is coming out of now a slightly different demographic. So these differences, however, are going to play out differently across different regulatory areas. So this first table, and this is table 6 from the document if you want to look more closely, provides what we would project as the percentage of U32 in the landings. One of the points of feedback that we got from our scientific review board the last time we did size limits, which I think was 3 years ago, was that a good size limit analysis should include specific predictions about how it might play out across different regulatory areas, so that we can then compare and see whether the response was similar to what was projected or not, and thereby interpret whether a potential change was good or not. And so in this document, we've tried to provide specific projections of what we think the changes might be on an individual regulatory area basis. And so what I've highlighted here, the left-hand column and highlighted in purple, is the percent of the landings that are comprised of U32 fish in a case where we have no minimum size limit. And the reason that I've called out those particular 4 IPHC regulatory areas, including Region 3, is that these comprise the largest range. So you see in IPHC regulatory area 2C, even with no minimum size limit, we would estimate that only 9% of the landings would be comprised of U32 Pacific halibut, ranging all the way up to 28% in 3B. And so this is going to have different effects on different parts of the fishery, corresponding to those areas that encounter fewer or greater numbers of U32 Pacific halibut. The next thing, and this is new, I don't think this has been calculated before for analysis of the minimum size limit, at least for Pacific halibut, was what we're calling the critical price ratio. And so we don't know what price potentially would be paid for U32 Pacific halibut. We might have some indication based on the prices that we saw from the FIS survey this year, but it could be a different landscape if it were a much larger share of the overall market. So rather than try to predict what kind of price might be available for U32s, we repackaged this in terms of a relative price relative to O32s. So now we don't need to think about what do we think the price will be. We can just think, well, what fraction of the price for O32s could it be? And I'll note that at the coastwide level, the estimate was 63%. So that means the critical price ratio is the break-even point. So we gain 7% yield if the price for U32s is only 60 cents on the dollar for O32s, then the fishery still breaks even. If it's more than that, if it's 70% or 80%, then the fishery actually gains value as a function of that additional yield. And so that's how to interpret this particular table. And you see that there is some variability across IPHC regulatory areas. While the coastwide level is 63%, not surprisingly, IPHC regulatory area 2B, with the highest encounter rate, that critical price ratio is 68%, meaning that a fisherman in 3B would need to get at least 68% of the price of O32s for U32s in order to break even, based on the additional yield that would be available from harvesting those fish. Now, I will note that we've not tried to be too sophisticated with this calculation. I'm no economist. In fact, I had to get help from an economist to do this analysis. And we noted that improved fishery efficiency could actually make this a somewhat better situation. So recall that there was an 18% increase in efficiency. Well, that's 18% potentially less bait and running time and time on the water and hooks turned. And so those are not parts of this calculation that are factored in. We've only just purely looked at the price ratio itself. So the paper includes a fairly wide-ranging discussion of a number of other considerations that are potentially important to the consideration of size limits. And I don't have time to go into them here. I'm certainly happy to answer questions about any of them. I will call out just a couple pieces, and one is the second bullet there, economic value. There's certainly a lot more that can be done beyond just this very simple analysis of price at the dock for U32s and O32s, and I think we've just opened the discussion with this paper on that front. The second one that I want to call out is the relationship between spawning biomass and recruitment. Because the IPHC is using a constant SPR policy, under any of these scenarios, we would be attempting to maintain the same relative level of fishing intensity or the same spawning output per fish in the stock. But adding or subtracting size limits would change the demographics of that. And I'll speak a little bit more to that here on the next slide, which is the summary table of the potential for these two management actions. So we evaluated just removing the minimum size limit and not a whole series of gradations. But you can interpret that any gradation between 32 inches and no size limit at all would have some intermediate effect to the values that I presented here. Similarly, we didn't have a specific directive on the maximum size limit shown on the right here, but we tried to find at 60 inches a compromise between something that would be relatively infeasible due to the encounter rate of those large fish, but yet something that would still have some of the same properties. What we've done in this table is to summarize the response across a series of variables that we thought might be helpful for making a decision about size limits. The first I've spoken to already, of fishery yield. The second, in fishery value, I've already spoken to. The third, with regard to discard mortality, noting that removing the minimum size limit decreases the discard mortality, and adding a size limit would increase the mortality and could actually further increase over time as we see a buildup of larger fish in the stock. Fishery efficiency, similarly to discard mortality, we would see an 18% increase with removing the minimum size limit and a 3% decrease by adding a maximum size limit. That corresponds to that 3% of the catch that would have to be discarded. One thing I have yet to speak to is the effect on our data sources. So by removing the minimum size limit, and thereby, if the regulation that all legal fish would need to be retained was retained, then we would actually have an improved data stream, because we would be able to sample import all of the fish that were being encountered by the fishery. It would actually potentially give us, just like we see from the FIS survey, an earlier view of incoming recruitment. In contrast, at maximum size limit, we would now not be able to sample those large fish. And so over time, we would have less and less certainty about the fraction of those large fish that were being encountered by the fishery. We would still have an estimate of those fish in the stock from the setline survey, but not so much a direct estimate of the encounter rates in the fishery, except as we can get from the ongoing observer programs. Finally, we considered encounters with large fish in the recreational fishery. This might be one of the most tangible benefits to a maximum size limit, would be you'd have more large fish in the biomass, and therefore the encounter rate would be higher. But just because we have more fish in the biomass wouldn't necessarily correspond to more spawning biomass overall, because we would still be balancing the same level of fishing intensity, and therefore we would likely be able to fish more heavily on the younger fish. However, to the degree that those older fish might be more successful at spawning, there could be a hidden benefit there that currently we have no evidence for a strong effect of increasing fecundity or reproductive success at large sizes or ages, but that is something that's been observed in other species, even though we have no evidence for that for Pacific halibut. Finally, we don't believe that either of these would change the demographics enough to change the average of projected recruitment. Recruitment seems to be driven as much by environment as by spawning stock, and so we think there would be little change and certainly no detectable change on that front. So the recommendations at this meeting are just to note this paper, and if there's anything additional that the Commission would like to see added to this, to request that now so that the Secretariat has time to address that before the annual meeting, IM097. So thank you for your time.
Thanks very much, Dr. Stewart. Any questions? Chris, go ahead.
Thank you, Mr. Chairman. Sorry, I have a big echo. Hopefully it's not coming across for you. Ian, thank you. I was going to ask, relative to slide 26, why the 3A and 3B discard mortality is so much higher than the other areas. And maybe my question is better asked is, why are there so many more U32 encounters in those two areas? Or is it just the absolute magnitude of the catch in those areas?
Through the chair, Commissioner Oliver, I think it's a combination of both of those things. The overall level of harvest is higher, and generally the higher the landings, the higher the encounters with sublegal fish. And so 3A certainly comprises a very large fraction of the coast-wide catch in a particular year. So that's definitely one factor. The second factor is that this is where the majority of these fish are distributed. So we see the highest encounter rates in some years in regulatory area 4A, but that doesn't translate into quite as high a mortality because that fishery is much smaller in overall magnitude. So the rates tend to increase as you go west in the Gulf, but the catch tends to increase as you go east. And the trade-off between those two things leads 3A and 3B to be the highest levels of overall mortality as a function of both of those factors.
Great, thank you. Can I ask, are y'all hearing this terrible echo?
No, we're not.
No, I wasn't hearing an echo.
Wow, okay. I guess I have a comment. I guess we're not poised to make a decision on this at this meeting, but when I look at the summary slide and all the information, I, speaking as one commissioner, would totally be prepared to make a decision on this. I think it's a no-brainer to look at removing the minimum size limit. So having said that, I just want to make sure that this is teed up for a possible decision point at the annual meeting. Thank you.
All right, thanks, Chris. Richard.
Yeah, Ian, I got a question regarding the encounters with large fish. So, I've been fishing for close to 40 years, and over the years I see the large fish, the encounters with larger fish have just been less and less. 10, 15 years ago would encounter a lot more larger fish. So what's happening in the fishery? Are we just, because of selectivity, both in recreational and commercial fisheries, just harvested all these large fish to the point where we have the overall population being younger and smaller, or is there anything to be said about fisheries-induced evolution, where you can genetically change the future of the fish by selective harvest? I just don't, I just see it in the fishery, and I don't have an answer for why we're encountering smaller fish these days than 20 years ago.
Through the chair, Commissioner Yamada, thank you for the question. It's a good question. Our understanding of the factors influencing size at age specifically is currently incomplete. We have a very active research program that Dr. Planas will speak about later on, trying to better understand the factors that are influencing the observed size at age. And it could be a function of many different sources. We have seen certainly a reduction in the size of fish at a given age. And so to the degree that the ages that are most frequently encountered are much smaller now than they were a decade or 2 or 3 ago, that will lead to lower encounter rates with larger fish. In addition, with the size limit in place, and also just fundamentally due to the size selectivity of commercial fishing gear, we would expect a higher level of fishing intensity on larger fish than on smaller fish. And so because of that, each cohort as it comes through, we tend to catch the fish that are fastest growing first, and we catch the more slow growing fish, and this would also be the males, later in their life at older ages. And so that also has an effect on reducing the observed size of fish over time. Now, the third component that you mentioned, fisheries-induced evolution, is a different process in addition to these other ones. And that the potential there, fisheries-induced evolution is where not only are we catching the fast-growing fish, but that the ability to grow fast is heritable, and the potential for that to be reduced in the stock over time. And this has been demonstrated in some experiments generally with small, high turnover species, but perhaps in some other commercially viable species as well. It's something that we don't understand for Pacific halibut, whether there is a potential for a long-term feedback. The places that we can look in the historical record are with regard to trends that we've seen historically. And so if we look back into the 1920s and 30s, we see that the fish in that time period were also quite small for their age. And then they actually got larger for their age over the time period from the 20s through the 1970s, which was a period of relatively high exploitation. And so we do have some evidence in the historical record against the theory of fisheries-induced evolution for Pacific halibut. However, we certainly can't rule out that it could be a contributing factor. The other component that we can look at is the variance in size at age. So if we were removing the genes for the largest fish from the stock, we would expect not only the average size to go down, but the variance should go down as well. The spread of size at age should also be decreasing over time. And that's not something we see in the data either. We still see a considerable range of sizes for a given age. And so I think currently the evidence doesn't suggest that fisheries-induced evolution is an issue, but I don't think we can rule it out either.
All right, Neil.
Stuart. I wanted to understand a little more about the implications of removing a size limit for how we estimate SPR. So if we saw, for example, retention of U32 or even targeting, what effect would that have on our estimates of SPR compared to something like avoidance, and then also kind of factoring in the discard mortality that would be associated with the current regime? Like, I'm just trying to get a handle on how this potential change would affect SPR and our estimates of that year by year.
Thank you, Commissioner Davis. Through the chair, It's a good question. There are several factors that are relevant. So as you note, the discard mortality itself is one component. So if you get rid of the minimum size limit, you gain almost 1 million pounds right there. But then, especially in cases where there's additional targeting, you're catching particularly the female halibut at a smaller size, and so you're having at a younger age, so you're having a larger effect on SPR. But then we're also accessing some of the male Pacific halibut at younger ages. So there's a number of different offsetting factors that will all affect the resulting SPR. The key is that these are things that we can measure and account for. So if, for example, if the minimum size limit were removed, there would be a lag as we transition into a fishery that's retaining these fish. So in the very first year, we wouldn't know whether there was targeting or avoidance. We wouldn't know ultimately the realized fraction of U32s. However, after a year of port sampling, we would then see how the fishery is responding and be able to incorporate that. And so those offsetting factors are why we don't just see, it's not as simple as just adding 1 million pounds onto the current mortality limits. The 6 to 8% range responds to a variety of different fishery responses and feedback levels to the SPR calculation. But moving forward, the stock assessment and the management procedure that we have is flexible enough to account for this kind of a change because it uses the information from the fishery to calculate and update on an annual basis the SPR that's being realized on the stock. And so in the absence of a minimum size limit, after a year's data, we would have an estimate of the fraction of males and females and the size range of those fish. And that would be incorporated into subsequent analyses.
So could I follow up on that? If let's envision
Yeah, go ahead.
Let's envision a scenario where maybe this is implemented and we are 3 or 4 years into it. Will we be able to do something like identify what effect it's had on TCEYs compared to what TCEYs would have been in the absence of eliminating the size limit?
Through the chair, Commissioner Davis, yes, we could do, once we had a couple of years of data in order to describe the fishery response and then effectively the selectivity of the fishery under these new conditions, we could do an analysis just like this one and say, what would it look like if we put the minimum size limit back in? Would we gain or lose TCEY? And in fact, that analysis in some regards would be easier to do because it would be more fully informed by data than this current analysis.
Any more questions, Neil?
Not at this time, but probably more in my future. Thanks.
Bob.
Yeah, Ian, thanks for the presentation. So I'm just trying to put some numbers together here. On the previous slide, on harvest potential, you're saying about 39 million TCEY. So if you round it up to 40 and you have 7% increase, that's 2.8 million pounds. And I see discard mortality is 0.8 of that. So the 2 million pounds more in yield, is that coming from an assumption that we're going to be taking male fish as opposed to female fish? Is that where the yield comes from?
Through the chair, Commissioner Alverson, yes, it does incorporate the fact that there would be more males projected to be harvested, but it also accounts for the fact that there would be more younger females, and at the current size at age, the evidence is that we would get a greater yield per fish harvesting them at a slightly smaller size than we have been. Given the current trends in size at age. So that estimate of yield incorporates all the various factors that are contributing to the fishing intensity.
All right, Peter.
Yeah, actually, a couple of my questions were already answered, just in terms of genetics and harvesting. But so we're in a position where we have a couple of young recruits. They haven't yet spawned into part of the spawning biomass. Where there's potential for even more because of a positive PDO from 2014 on. Do you see this fishery yield changing over time? Like, is this if we did it last year, it would be this, but into the future, it may be different because, yeah, just if you understand what I'm asking.
I do. Through the chair, Commissioner DeGreef, yes, this would certainly be dynamic over time. And I think you've identified exactly the factors that would probably be most influential if we had a year or series of years where we had very large incoming year classes that were encountered by the fishery in great numbers. That could potentially change this trade-off. This balance between U32 and O32 will be variable over time. However, I would look back to the historical analyses and just note that those have occurred now a handful of times over the last several decades. And each one has come up with largely a similar conclusion over the last several evaluations, that there is some additional yield to be had, regardless of the particular recruitment dynamics that were occurring at that time. But this is definitely something that the relative benefits would change from year to year.
Just considering that, would it be best to run this through some sort of management strategy evaluation, just because there is this time and dynamic and long-term effects possibly? Or?
Thank you. Through the chair, Commissioner DeGreef. Yes, certainly testing components of a management procedure as part of a simulation before trying them is always a good idea. I guess I would encourage the Commission to ask my colleague, Dr. Hicks, the same question and the amount of work that it would take and or prioritization of size limits over other topics and whether that would fit into the current MSE to actually do that. But certainly that would be, we could learn, there are things we could learn from that process as well, particularly how variable this might be over time.
Thank you very much. Very good. It was a very good read and a thorough document. It was very interesting to me. Thank you.
Yeah, okay. Just want to do a check, Dave, on the agenda. I note for tomorrow on agenda item 9, I don't think there are any presentations for that item. Is that correct?
That is correct, Chair. Yes, we don't have any presentations scheduled for agenda item 9.
Okay, so that frees up a little bit of time on the agenda. So this would be the time to take public comment and questions. And so, Dave, maybe you could lead that if you have the comments and questions, and we could go through those.
We have 6 comments, whether it be written or verbal requests. So have the Secretariat bring up those questions on screen as well, so it's easier for all participants to see them in real time. Just project that, please. So we have 5 of the 6 are simply written questions that I'll read out and then we'll have somebody respond to. And one of them is a request for a verbal intervention, which we will go to as well. So let's move to question number 1. Just want to make sure that's optimized and that the size limit presentation is not visible, and I can't tell whether that's the case or not. Okay, so the first question, it's a written written question from Mr. Chuck Ashcroft, the Sport Fishing Advisory Board of Canada. And the question relates to agenda item 5 on the state of the fishery. And so Ms. Lara Erickson will respond to this as it comes up. So the first question, it's in 3 parts. So the first part of the question, as shown, is that could you please advise whether or not the recreational sector in Alaska is accountable for and responsible for their release mortalities? Now, having read that question again, I'm not sure Lara's the particularly right person, but Lara, if you could respond to that first part, and then we'll jump on to part B.
Yes, thank you. Yes, thank you, Dr. Wilson. Okay. The removals in the recreational fishery in Alaska are reported in paper 5 and table 2. They are, it depends on whether they're part of the guided or unguided sector, but yes, they do go into the overall mortality
Thank you.
limit.
Then part B is if so then, and that indicates that it is. Are these recreational release mortalities deducted from the Alaska Recreation TAC, i.e. responsible and accountable? And noting that Canada deducts anticipated release mortalities directly off our recreational TAC before the final TAC is established. So if you'd like to respond to that.
Yes, thank you, Dr. Wilson. And for it, again, it depends on the recreational fishery type. For the guided fishery, it is part of their total TAC, their discard mortality. But however, in the unguided, it is separate from the, well, there's no fishery limit.
Thank you. And
sorry,
part
for the
C,
unguided.
and I'm not sure if we can entirely answer this one, but what 2019 data is being used by IPHC to determine the number of fish released in the Canadian recreational fishery as part of the process to determine the release mortality being charged against the 2020 fishery?
Yes, again, thank you, Dr. Wilson. So we actually use a rate for IPHC regulatory area 2C. The rate of discard mortality to the harvest amount is then applied to the harvest amount for IPHC regulatory area 2B. However, the discard mortality is based on an average size, which is a result of the surveys that take place in Alaska. And I would need to bring up the paper by Sarah Webster to reference that value.
We might just source that value and then also put that out either tomorrow or just simply send that along to each other. Okay, the second question that we have is a request for public comment from former Commissioner Don Lane. It relates to agenda item 6 on the status of Pacific halibut, the harvest decision table. And so, Don, the Secretariat is activating your microphone. If you could just do a quick sound check, and then you can go ahead. You there, Don? We seem to have a slight audio connection issue with Don, and so what we'll do is we'll come back to this question. The Secretary can continue to work with Don in the help channel to get him activated, and then we'll come back at the end of the series. So moving on to the next question, it's another written question from Chuck Ashcroft. This relates to agenda item 6, the stock status of Pacific halibut and harvest decision table. Document 6, is there increased uncertainty in determining distribution percentages for 2021 based on a lack of FIS surveys taken by IPHC other than in regulatory areas 2B, 2C, 3A, 3B, which meant the 2019 NIMS survey was used to determine distribution regions for the I'll pass to Dr. Stewart and Dr. Webster to answer that question.
Thank you, Dr. Wilson. I'll take this, and Ray can add to it as he sees fit. Yes, there is certainly increased uncertainty in determining the distribution percentages due to the areas that were not sampled in 2020. We see that in the variance estimates. However, because we did sample extensively across the majority of the stock distribution, the overall percentages, particularly to those areas that we did sample, the effect of these missing areas is much lower. So the areas that we didn't sample, put another way, the areas we didn't sample comprise a relatively small fraction of the total. And just a minor clarification that the 2019 NIMS survey was not used to determine the distribution for 4 and 4B. Those, again, like other regulatory areas, those are based on the projection of the space-time model in the absence of new data.
Dr. Webster, anything to add to that, or shall we move on?
Having a hard time hearing you, Dave.
Ask is not very conducive. You hear me now?
Still can't hear.
Hi. This is Ray speaking. Can you hear me?
Yes, go ahead, Ray.
Yeah, can hear you.
I was only just made a presenter. I don't have anything to add to Ian's comment. He's correct. We have precise estimation of stock distribution in the core areas, and those other areas are relatively small component of the stock, and so they are less precisely estimated than they were in past years, but it doesn't add up to a big impact on how we understand the stock is distributed.
Great, thank you very much. I'll move on to the next question. It's from Robert Hawkness, Canadian commercial fisherman. It relates to agenda item 5, state of the fishery, the preliminary statistics. So this will be for Lara Erickson to potentially respond to. Is there a reason why Canada's directed discard mortality is up compared to the other regulatory areas? And so it's also maybe for commissioners to respond to. So first, Lara, go ahead.
Yes, thank you, Dr. Wilson. There was an increase in reported discard mortality in the directed commercial fisheries. So there was reported more Pacific halibut that were 032 reported by the fleet. And if I may, just following up on Chuck Ashcroft's earlier question, it is a rate that's used for IPHC regulatory area 2C that is then applied to the recreational discard mortality for 2B. However, that rate is based on the total removals, and we do have a fish count as well as an average weight for those fish in 2C. But again, it's a rate, so the weight and the number doesn't necessarily apply in that instance.
Thank you very much, Lara. Thank you. So moving on to the 5th question. This is from Tom Marking, the Humboldt area saltwater anglers, relating to agenda item 6, stock status of Pacific halibut and the harvest decision table. So the question is, comment and question is that Northern California has a substantial migration of juvenile fish, 26 to 30 inches, move into the Eureka area this summer. While California Department of Fish and Wildlife chose not to measure any lengths for this summer because of COVID, they ascribed a 21.72 pound per fish based upon the previous 6 years of catch history. In reality, the average fish was probably more in the 10-pound range. Thus, the 64,587 pounds projected was grossly overstated. Our angler success was probably 0.95 rather than our customary 0.35, albeit they were very small fish. The point being, we had an abundance of small fish migrate into our area, a condition not seen for over 15 years. And so I guess that's more just a comment for Commissioner's consideration. And then the final question, written question we have to date, I see a few others coming in that we can take later, but the final one we have prepared is from Dan Falvey from Alpha, relating again to agenda item 6. And this is that Ian's slide 58 shows that O32 abundance in 2B with current relative harvest HRs would give 2B 11.6% of coastwide TCEY. The interim agreement increases this to 17.9%, which effectively transfers 6.3% or 2.4 million pounds of the coastwide TCEY from the USA to Canada. So the questions are, does this effectively increase the fishing pressure on the stock in 2B to 150+% of what O32 biomass and relative HRs would otherwise recommend? And the second question, in 2020, the interim agreement effectively transferred 4.7% or 1.7 million pounds of coastwide TCEY from the US to Canada. Why is the relative percent and absolute amount of TCEY transferred to Canada increasing in 2021 when the halibut stock is essentially stable and coastwide TCEY is going up? And so I'll pass that to Dr. Stewart.
Thank you, Dr. Wilson. Obviously, I can't check these numbers on the fly here for accuracy, but if I understand the gist of the question, yes, the fishing pressure on the stock, based on the agreements in IPHC regulatory areas 2A and 2B, the fishing pressure on the eastern side of the stock would be estimated to be higher than applying simply the baseline from the interim management procedure. And that would apply to all of the biological region 2, because as we understand it, those fish are mixing even within a calendar year. So that would apply not just to the 2A and 2B, but also to 2C as well at a higher harvest rate. And I'm not sure, without actually comparing the numbers, exactly how to answer your second question, except to say that as the percentage of the stock in IPHC regulatory area 2B differs from 20%, the effect of the weighted average becomes more pronounced. And so I suspect that's what you're seeing in the numbers, is that the weighted average with 70% of 20% is more important this year than last year, because it's the estimate, the raw estimate in the baseline of stock distribution is slightly lower.
Thank you very much. So that sums the questions we currently have. I just wanted to check to see if we managed to get former Commissioner Don Lane online so that we could have him ask his question directly. Don, are you there? Content is, and then we will allow a bit more time for Don to comment. Unless, Don, are you there? No. Okay. So through the chair, I see there are commissioners who would like to ask or comment. So I'll pass back to you, Chair.
Yeah, thanks very much, Dave. Neil, do you have a comment? Was your hand just up from before?
I think that's residual. Oh.
Okay, thanks. So I don't see any other questions or comments from commissioners, at least on the screen I'm looking at. So, Dave, you said there were some more questions and comments that had come in, but we'll deal with those at the next session. Is that what you were suggesting?
Yes, we just have to get them uploaded, and I also see that Forrest Braden has flagged an earlier question. So we'll just put those into the presentation and take them before we close today, if that's all right, and make sure we cover them before we close.
Sure, let's do it that way. And with that, then we would move on to the next agenda item in 7, where Dr. Planas will give us the report on science and research.
I also just note we have a couple of external presenters that are scheduled for today. Given we're running a little bit behind, but neither of them are available tomorrow. They've both requested if we can move them up before we close at 5 o'clock today. So that's Sean Cox, who's the chair of the Scientific Review Board, and we're well on track to get to his presentation, but also Trevor Branch, who's going to present the independent peer review of the MSc. So maybe doing Dr. Planas with the Research Advisory Board, then going in to ensure we get the Scientific Review Board, and then jumping to agenda item 8.2, if that's permissible, Chair.
Yeah, that'd be fine for sure, Dave.
Okay.
Let's do
Thank
it that
you.
way.
Over to Dr. Planas.
Thank you, Dr. Wilson. And through the chair, I will speak to the report of the 21st session of the Research Advisory Board that took place in Seattle on 26th of February of this year. The meeting was attended by 9 of the Research Advisory Board participants, and they made a series of requests and recommendations, which I'll highlight here in a second. In fact, there were no recommendations, but there were a total of 8 requests, and those were the following ones. Request 01 from the Research Advisory Board was that the IPHC Secretariat consider how environmental monitoring could continue in areas where fish sampling is not taking place in a given year, in particular to help understand environmental trends in IPHC Regulatory Area 2A. Request 02 was that the IPHC Secretariat consider investigating the possible effects of hook differences on fish results. Request 03 was that the IPHC Secretariat consider the effect of different bycatch species on hook competition rates. Request 04 was that the IPHC Secretariat consider additional ways to incorporate commercial fishery data into stock assessment. Request 05 was that the IPHC Secretariat engage with stakeholders who have performed fish work in the Western regulatory areas to improve the design and feasibility of the fish, including the possibility of multi-year fish contracts. Request 06 was that the IPHC Secretariat conduct outreach with fishers and enforcement agencies related to the issue of the fact that tagged fish, or IPHC tagged fish, do not count against regulatory limits and therefore should be kept. Request 07 was that the IPHC Secretariat consider migration studies specific to IPHC Regulatory Area 2A, given that it represents the southernmost range of Pacific halibut distribution. And finally, Request 08 was that the IPHC Secretariat review the definition of washed fish and the weight deduction that is applied for washed fish. And that is all regarding the request of the Research Advisory Board.
Sorry, Chair, there's a slight technical issue here, so we're just going to get it all back online and come back to you.
Yeah, for sure. No problem, Dave.
Did you hear Dave and Paul just now? Yes, I did. So you're good? Yeah, I can't hear you. You can hear me?
Okay, so it sounds like we're good to go. I can hear you there, Giuseppe. So it sounds like you've wrapped up the presentation, and we'll pass back to the Chair to see if there are any questions on the Research Advisory Board. So over to you, Chair.
Yeah, thanks, Dave. Sorry. One sec, having a problem myself. There we go. So are there any questions for Giuseppe? I'm not seeing any at this point, Dave. Or excuse me, Dr. Planis. So I think we can move on.
Can you see me there, Paul?
Oh, yeah, sorry, Peter. I didn't scroll down far enough. Go ahead, Peter.
Yeah, no problem. Just on request 3, consider different effects of bycatch and competition. Is there any idea on how one would tackle such a topic for research?
Through the Chair, thank you, Commissioner De Grief. I think I will pass the word to Dr. Stewart or Dr. Webster, who are better equipped to answer this particular question.
Thank you, Dr. Planis. Through the Chair, Commissioner De Grief, this is a challenging topic to research. The challenge here is the question of whether some species may have access to the gear before others. And so the only real ways to get at that directly are either through some type of video work or through some type of use of hook timers, whereby we can determine how long the gear was in the water and at least determine whether the gear was settled to the bottom prior to a capture of a particular species. I think the primary concern with this item was the capture of dogfish potentially occupying those hooks before they reach the bottom. So this is potential research that would be challenging and likely expensive to conduct, but certainly we're giving it more thought because it's a interesting avenue for further understanding.
I suspect it's very expensive to try. The technology doesn't quite exist, or it's expensive at this point, but it's something that we are monitoring and looking at in the future.
Through the Chair.
Thank you, Commissioner. I think.
Go ahead, Dr. Stewart.
Sorry, Dr. Planis. I think that there is some technology available, but the biggest cost would be that this would take some very directed and experimental work on the water, which, as we all know, is quite expensive, especially these days. So I'll defer the rest of the answer to Dr. Planis.
Through the Chair, thank you for your question, Commissioner De Grief. Yes, as Dr. Su indicated, this is something that we need to carefully evaluate due to cost, but there is in the next iteration of the 5-year research plan a section on interactions with fishing gear, and we'll definitely contemplate that issue. Thank you.
Thank you.
All right, thanks. Any further questions for Dr. Planis? Not seeing any at this point. Then, Dave, did we want to go over to Dr. Cox?
Yes, that's correct, Chair. So we'll move to, we're actually still in sequence, which which is good. So we're in agenda item 7.2, and this is a report from the Scientific Review Board Chair on the outcomes of the SRB this year. And so, Dr. Cox, if you could just turn your microphone and video on if you're available, we'll do a quick sound check and then proceed.
Hello. Do you hear me?
Can hear you fine.
Mm-hmm. Thank you. Is somebody going to advance these slides, or am I? Okay, there we go. Okay, so I'm going to summarize the SRB meeting we had back in September. Next slide, please. These are our SRB members, as I've said before. To remind you, our summer session in June is normally focused on research, and then our September meetings are typically focused on the information that is going into the stock assessment for that year, as well as other issues that are topical. In this particular year, we focused mainly on the FIS rationalization and the sampling designs and the MSE. Next slide, please. We only had recommendations for this September meeting. The first one being, sorry, I need to resize my screen a little bit here so I can see. The first one being we endorsed the 2021 FIS design that was proposed to us. Next slide. This is the one, and there were others presented in one of the appendices to our report, which was the full 2022 and 2023 ones as well. Next slide. So one of the things that we had recommended for the biological research program was to add some prioritization of research components, specifically tying them to particular uncertainties within the stock assessment and MSE. Continuing to try to improve the integration of the biological and ecosystem research program into these other main functions. One thing we suggested, for example, that the biological uncertainties could be ranked in a prioritized order for the stock assessment and MSE would be one way to do it. Next slide, please. There was a recommendation about trying to establish or recommending that the Secretariat establish a series of benchmarks, statistics that characterize the Pacific halibut genome, since that was a major step forward. Next slide, please. Again, with research integration, this is similar to the one before. Trying to encourage the Secretariat to prioritize research activities and to also put timelines on them as to when those research products will be integrated into the assessment and the MSE. And recommendation 5 was trying to get more specific direction to what the SRB is expected to provide input on and decisions about, trying to get those things into the documentation that are presented to us. Next slide. These three relate to the management strategy evaluation, and there are 3 ways that estimation error is incorporated into the management strategy simulations. And we recognize that the current approach that's being used, which is kind of an approximation of an assessment, is fine for the stage that the MSE is at now, but we recommended that the Secretariat continue to work towards actually building assessment models into those simulations so that they better represent the way the assessment is actually done from year to year. Recommendation 7. So this particular one it's getting to the issue of, is it better to adopt a management procedure that is tested under a wide range of uncertainties, but certain things still remain unknown? For example, migration rates are not very well characterized for halibut, but there's a lot of other uncertainties that are dealt with in the current MSE. So this one, we recommended that the MSE continue to compare these management procedures, but just consider that it might be better to adopt a simulation tested management procedure than to continue to use an untested one, which is the current approach. That's the main recommendation here. And 8 is related to something called exceptional circumstances, which is used in other MSE contexts. And this is a situation, it's for situations in which the data that are coming in are inconsistent with what has been simulated and used to test the management procedures. This kind of topic is used in a couple of different fisheries. It's basically one where if someone wanted to opt out of a recommendation that came out of a management procedure, they would need to point to specific evidence that suggested the procedure was not working as intended. And so exceptional circumstances provide the criteria for establishing that evidence. So it's not something that you can come up with overnight, but it's definitely something that the Secretariat should start to think about and work on. And I think that's it. Next slide. Yes. I'll take any questions.
Thanks very much, Dr. Cox. Are there questions for Dr. Cox? I have one. If we could go back to slide 6. So I'm not quite understanding here what you're stating, I guess, in this recommendation, Dr. Cox. I understand about adding the clear prioritization, but you suggested a way of doing that. Maybe you can just expand upon that.
Well, it's the assessment and the MSE, they always have uncertainties that they're dealing with. And I think if you sat down with any of the scientists, Ian, Alan, and others, and you asked them what is the most important uncertainty in your assessment or in your MSE, they would be able to tell you that. And they would probably give you 2 or 3, and they would be able to rank them. And so this particular recommendation is about the table that's presented to us in terms of the planning of the research. And so what would help us and everyone, I think, would be to go through that exercise and actually rank those particular uncertainties and show how they're integrated into the table. So, for example, you wouldn't want to have your most important uncertainty, not dealt with for another 10 years. I think that's what we're trying to get at.
Okay, thank you. That helps me understand, and maybe I could turn to Dr. Planis and see what he thinks. Maybe he's done some work on this already, or has thought of ways about moving ahead with setting a prioritization for biological research.
Thank you, Chair. Yes, we have, as a result of the comment from the Scientific Review Board In fact, the Secretariat has already started to rank the priorities based on stock assessment and MSC research, precisely as Dr. Cox indicated, to make sure that we're not leaving out any essential or high priority issues related to stock assessment and MSC outside of the research activities scope. For example, we have now completed a table, or I would say a first draft of a table in which we have all the prioritized inputs from stock assessment that would require research activities, starting from biological inputs to assessment, data collection and processing, as well as fishery yield. And the same with the MSC process, namely biological parameterization and validation of movement estimates, as well as fishery parameterization. So that is work in progress, and we're definitely working in the Secretariat to achieve that goal. Thank you.
Great, thanks very much for that reply. Are there any other questions for Dr. Planas or Dr. Cox? No, it looks like we could let you go then, Sean.
Okay, we'll have a good meeting. Thank you very much.
Appreciate the update.
Thank you.
Okay, well, thank you very much, Chair. The next, as I said, we're going to change the agenda around slightly, and we're going to bring agenda item 8.2 forward so that we can have Dr. Trevor Branch present the MSc peer review. So if we could have the presentation for the independent peer review up on the screen, please. Just going to give a quick introduction to the peer review itself before I hand over to Branch. To run off the big screen. So if somebody could advance the slide for me as well, that would be good. Many hitches at the moment. So to provide a little bit of context, this paper is being provided to you, noting that its core aim is to provide an opportunity to further consider the report of the independent peer review of the IPHC's management strategy evaluation process. So if you cast your minds back, this is a process that you agreed to and requested, and you also enforced the terms of reference and associated elements at IM096. The IPHC Secretariat undertook an expression of interest and recruited Dr. Trevor Branch, who's an associate professor at the School of Aquatic and Fishery Sciences of the University of Washington, to undertake the independent review on our behalf. The report from Dr. Branch that he's going to walk you through was provided in draft format to the Scientific Review Board, as you've just heard, at the 17th session of the SRB in September of this year. And the SRB provided additional feedback and thought on the draft report directly to the peer reviewer, independent of the Secretariat, subsequent to the meeting itself. As a result, the final report was published on the 25th of September via IPHC Circular 2020-022, and the report has also been made publicly available on the Management Strategy Evaluation page, and we provide you the link to that page in this presentation and also the associated paper. The Management Strategy Advisory Board considered the final report while making its recommendations as part of the MSAB 16 report, and you'll hear some initial feedback in that regard, most likely tomorrow morning at this stage. So, Chair, at this point I would like to pass to Dr. Trevor Branch to introduce himself and then walk through his findings. And Trevor, I'll simply advance the slides from here for you. So Dr. Branch, over to you.
Okay, thank you very much. Thanks for the opportunity to share in this forum. If you can go to the next slide. So my terms of reference that I was given were to provide advice on and contribute to a subset of the following: to review the goals and objectives used to evaluate the management procedures, review the closed loop simulation framework, review and advise on the operating model and how it's conditioned, review the tools and methods used to communicate to evaluate the management procedures, evaluate how objectives were solicited from stakeholders and managers, and how performance metrics were created, assist with developing and defining reference points and management procedures, and advise on the methods used to communicate the results of those, the trade-offs between the management procedures and the ranking of management procedures. So go to the next slide. So what I went through and did was I reviewed documents and decisions from recent IPHC meetings, including the MSAB, SRB, and commission meetings, the independent peer reviews of both the IPHC stock assessments, the performance review of the IPHC, and the main stock assessment documents and MSC documents. I also attended the August informational meeting presenting the preliminary results. Members of the MSAB conducted a series of informal conversations with what I tried to make a diverse array of MSAB members, including the team itself, scientists, managers, industry representatives, and so on, and then present some interim recommendations to the SRB meeting in September for feedback. Next slide. So my findings, and I just would take a step out away from all the PowerPoint slides and say that I didn't find any major issues. Generally, everything was conducted according to international standards. So that's the sort of top level finding. So as everybody knows, the MSC is intended to simulate test rules for setting catches for halibut and how to allocate catch and bycatch amongst the IPHC regulatory areas. And in my judgment, the MSC is technically sound. I found almost universal praise from all of the participants that I chatted to for the MSC team led by Dr. Alan Hicks, for their technical work, for their collaboration with stakeholders, and the communication of results to the stakeholders. So I didn't identify any issues amongst the people that I interviewed or the work that I reviewed.
Looks like we may have dropped a connection there. We'll just wait for a moment to see if we can get Dr. Branch back.
Guidelines. Sorry about that, everybody. My internet has not been great. So as it's set up, it has a simulated model of truth operating model, a simulation of the stock assessment process, the estimation model, and a simulation of the catch setting and the catch allocation process. In other words, the harvest control rule. So next slide, please. So what I did find in terms of recommendations for changes were mainly to do with process. I really felt that to ensure that the MSE simulations continue to be successful and accurate, primarily a decision needs to be made about what is the future of the MSE process beyond January 2021. And the reason for that is that several of the key members of the MSE team, their contracts end, and it's not clear what the priority is for the Commission beyond that time point. If it's to be considered a continued high priority, then my recommendation is that sufficient funding be continued to be allocated, but regardless, to figure out what the future is of the MSE process beyond the beginning of next year. The second finding is that the MSE framework, in my opinion, should be treated as an ongoing process that's going to be used over many years alongside the stock assessment, so that you can use it to test the effectiveness of the kind of data you gather, the assumptions that go into the stock assessments, and how the catches are set within IPHC. A third recommendation was that the Commission should codify the rules that they use to adjust catch levels within each regulatory area after applying the harvest control rule, so that the MSE framework can accurately evaluate risk to the stock and catches within each such area. And the reason for this recommendation is that there is a step in the setting of mortality limits where the Commission decides how to adjust those by area that is not currently incorporated in the MSE process. And this process of adjustment is done with the best of intents, and all participants that I chatted to said that they agreed that it should continue being done. It's just that it's not simulated within the MSE, and the concern would be that if you don't simulate how the catches are actually set and implemented correctly, you're not going to get a fully accurate MSE set of predictions. Next slide. So my priority recommendations were that the Commission should plan ahead for the future of the MSE process and allocate required funding and personnel accordingly. It be treated as an ongoing process to be used each year alongside the stock assessment itself, and to analyze the impact of the Commission modifying catch levels in each regulatory area after the TCEY recommendation from the harvest control rule. Such analysis should be conducted using the MSE and be based empirically on past Commission modifications. And the reason for that is that since catch setting is an integral part of the MSE, it will be most accurate when it models the actual decision-making process of the Commission itself. Next slide. Additionally, there was certainly some room for the MSAB membership to be expanded to include representatives of some areas that are not currently very well represented, such as crew members, fishing communities, environmental organizations. I didn't see this as a high priority recommendation, but certainly something to continually reassess and look at. And then to recommendation 5 was to complete the documentation of the technical details of the IPHC MSE framework. Currently, that's a somewhat incomplete working document, and it would be good to ensure that the methods are repeatable by including a complete description of those methods at the same time as the finalized results for next year's meeting. Okay, any more slides? I think that was it. So I'm happy to answer any questions, thoughts, comments from that. As I said, overall, I didn't find any major concerns. Everything is done according to international standards, and indeed, I would say that the team itself was supported by the stakeholders in a way that I've rarely seen in an MSE process before.
Okay, thanks very much for your peer review of the MSE process and the recommendations that you've brought to the Commission's attention. I see a number of people have some questions. I will start with Commissioner Oliver.
Thanks, Paul. It's really not a question, it's a comment, I guess, with regard to recommendation number 3 and somehow codifying the process after the harvest control rule by which we might vary regulatory area recommendations or solutions. My only comment there is that it's quite variable. It depends year to year on a number of factors. It might be difficult, if not impossible, to actually codify that. Any reactions?
Yeah, I do appreciate it. Yeah, sorry.
That's all.
Yeah, I do appreciate that's not an easy process, and I would say that if it's the case where there are no clear set rules for how you make those modifications, that one way of incorporating that into the MSE would be to say, okay, the MSE predicts this set of catches or mortality limits in each region, but then after that, there's going to be some uncertainty you add to that might differ from year to year, such that the recommendation that comes out of a harvest control rule is not implemented exactly as that number, but then that number might vary, and then look back at the last 5 or 10 years and ask, well, how much does it vary from that to the final number, and try and draw values from that range so that you're perhaps imperfectly, but at least capturing that extra uncertainty in how it's implemented.
Thank you.
Neil.
My question was very similar to Chris's, but maybe I'll just take it a little further. I wondered if there were examples in other contexts that you would point us to, Dr. Branch, of that particular issue. And I think most relevant would be examples where you have two or more parties that are attempting to reach agreement on catch limits. I'm aware of at least one domestic example where we do a pretty good job of codifying the rules and following them year to year, but I think something like the IPHC is a unique context.
Yeah, I think every fishery has its own unique context and a way in which the politics and economics and fishery sustainability are traded off against each other. In other places where I've been involved in MSEs, typically the MSE has actually been, or I should say, for a management procedure where you're trying to find a rule to manage your fishery and set catches according to the rule. The MSE has actually been developed specifically to avoid that year-to-year wrangling amongst stakeholders. So the IPHC in that sense is somewhat unique. So for example, a case from South Africa, typically every year they would come, they would do a stock assessment, there'd be a recommendation for a catch level, and then the industry would argue with the government, and they'd wrangle backwards and forwards about what it was actually going to be, and they would inevitably set it at a somewhat different number. And they agreed after some time that this annual wrangling over what the catch was going to be wasn't good. And so they developed an MSE that would test all the rules and come up with a rule that would work best. And once they decided on the rule, then that rule would set the catch every year without any wrangling between industry and government. And the same thing was true of the CCSBT, where they do it for southern bluefin tuna, where multiple countries were involved, and Japan and Australia and New Zealand, Taiwan were all arguing over what the catches should be, and inevitably the actual catches that were set were far higher than the science would have recommended because of that political wrangling. And so over the period, far too long of a period, I would say about 10 years, they developed a rule that everybody agreed with, and that rule is how they set the catches now. So there's no political wrangling. That wrangling was done beforehand, before they decided on the rule. So for the IPHC, it's a little unique in that the intent of doing the MSE is not to come up with a rule that avoids that, but for the MSE to give accurate results, it needs to account for whatever process there is after the recommended TCEY gets allocated, to ensure that when you evaluate how well that rule performs, you account for all of the aspects of management that go into it.
Okay, thank you. So commissioners would be planning their own obsolescence. Frightening prospect, but appreciate the input.
But on that note, when I was working at CCSBT, I exactly did that. As soon as they adopted the rule, they no longer needed my services. Any other questions?
I'm not seeing any. I was just doing another check, but I see no other questions for you, Dr. Branch. So again, thank you for your presentation and your review of the MSc, and yeah, thanks very much.
Thank you, everybody, and all the best for your deliberations.
So Dave, do we want to go back to public comment now, or do you think carry on with MSc and then do public comment and questions?
Thanks, Chair. We actually have agenda item 7.3 remaining. It would take about 20-25 minutes to complete. So that's the update on the 5-year biological and ecosystem science research plan by Dr. Planas, and that will then leave us with probably a good half hour or so to take remaining public questions and comments from the presentations today. If that's
all right, thanks. I'm sorry I was getting ahead of myself again. Sorry about that, Dr. Planas. Yeah, no, that's fine.
Great, thank you, Chair. Could I just request a quick confirmation that the audio is correct?
I can hear you well.
Okay, great. Thank you, Chair. Well, good afternoon, everybody. What I would like to do here is to provide you with an update of the 5-year biological and systems science research plan. I'll be speaking to agenda item 7.3, and the document is IM096-10. The outline of the presentation is first to highlight the key components of the 5-year biological and systems science research program, but really focus on updates on ongoing research projects within the IPHC Secretariat. If I go to the next slide, I would like to highlight that the primary objective of the biological and systems science branch within the IP Secretariat is to conduct biological and ecological research that informs both the stock assessment and the MSc, as well as conducting basic and applied research to improve our understanding of all aspects of the Pacific halibut biology and its interactions with the environment and the fishery. The biological and system science branch receives input, obviously, from both stock assessment and MSc, but also from 2 of the IPHC subsidiary bodies, namely the Research Advisory Board and the SRV, that review research that is proposed and conducted by the IPHC Secretariat. The IPHC Secretariat's Biological and Systems Science Research Program is conducted under the current 5-year research plan that identified 5 primary or key research areas, and those are indicated here in the left column. The first one is migration, the second one is reproduction, the third one is growth, the fourth one is discard mortality rates and discard survival, and the fifth one is genetics and genomics. We're now in the process of developing, as I mentioned before, a new 5-year research plan that will incorporate some of these ongoing activities in addition to novel ones. If I may move to the actual progress on the various research activities, let me start with the research area on migration and distribution. And here I would actually like to highlight the results of a study on larval and early juvenile dispersal that the Secretariat has conducted in collaboration with scientists at the Alaska Fisheries Science Center in Seattle from NOAA Fisheries. And the key findings are that the large island passes within the Aleutian Islands act as conduits between the Gulf of Alaska and the Bering Sea, and that there is a high degree of interbasin larval connectivity that is influenced by the spawning location. So in this study, an individual-based biophysical model was used to estimate the potential passive transport of larvae from known spawning grounds, both in the Bering Sea and in the Gulf of Alaska, to the Bering Sea. And in fact, in this map on the lower right-hand side of the screen, you can actually see from 1 to 5 in different colors the five known spawning grounds that have been described for Pacific halibut. So if we take, for instance, spawning area number 1, which is the one highlighted in the Bering Sea, we can actually estimate that 100% of larvae that are spawned in that spawning ground will actually be transported to the Bering Sea. And in this table you see on the first column the 5 spawning areas from 1 to 5, but then on the x-axis you see 6 different years, 2003, 4, and 5 representing examples of warm years, and then 2009, 10, and 11 representing cold years. And here you can see highlighted that 100% of the larvae that are spawned in the Bering Sea, as I indicated, is it estimated that they will end up in the Bering Sea. Interestingly, the spawning grounds in the Gulf of Alaska, the production of larvae, according to the model, will have different outcomes in terms of their connectivity to the Bering Sea. If you look at spawning area number 2, in fact, between 47 and 58% of those larvae are actually estimated to arrive to the Bering Sea, so therefore contributing to the Bering Sea nursery areas. Spawning area number 3, which is in the central Gulf of Alaska, is expected to produce larvae that will be transported to the Bering Sea in lower percentages. And here you can see that between 15 and 20% of those larvae from spawning area 3 may be transported to the Bering Sea, and lower percentages of larvae transported to the Bering Sea as we move towards the easternmost spawning areas. So one of the additional outcomes of this study is that there is increasing evidence for a large degree of intra-basin connectivity within one ocean basin. And here we can see what happens in the Bering Sea, particularly in spawning area number 1, which is the one in the Bering Sea. So here in this diagrams, you can see in 2005 a warm year, and 2009 a cold year. The distribution and the trajectories and expected trajectories of larvae that are spawned in this spawning area. In pink, those are the outcomes of larvae modeled to be spawned, and after 5 months after spawning, therefore reaching the northwestern portion of the Bering Sea in both years. If we compare that to spawning area number 5, which is the one in the southeast Gulf of Alaska, we can see that in pink, again, those larvae are actually transported coastwide, but do not reach the Bering Sea. When we follow the 2005 cohort that was actually mentioned by Dr. Stewart in his presentation as 2, 4, and 6-year-old juveniles with the use of the space-time model, we can see that these fish are actually moving out from the inshore settlement areas. If you look at the top drawing on the right, you see H2 fish from the 2005 cohort, mostly concentrated in the inshore settlement areas in the northeastern Bering Sea. and how those fish are actually moving out of the Bering Sea towards Unimak Pass and into the Gulf of Alaska, therefore demonstrating that those fish actually migrate out from the northern Bering Sea and eventually repopulate the Gulf of Alaska. So the results of this study have now just been published very recently in the journal Fisheries Oceanography. If we move into the second research area, which is reproduction, Dr. Stewart has extensively commented on the sex ratio information that the IPHC Secretariat has provided for the last 3 years in the commercial landings of 2017, 18, and 19. And here I have to say, and I have to give thanks to both the intern and particularly to the IPHC laboratory technician, Ms. Anna Simeon, for conducting this in record time. You have heard the sex ratios from the commercial landings, but due to the importance of those sex ratios now in scaling spawning biomass, the IPHC Secretariat started looking into the possibility of evaluating sex ratios in historical samples. Due to the fact that genetic samples are not available prior to 2016, but otoliths are archived and available for those kind of studies, we evaluated the possibility of isolating DNA and conducting genetic assays for sex identification using otoliths as a source. And initial results from freshly collected otoliths and dried were successful in the fact that we could actually isolate DNA and identify precisely the sex of those individuals using our genetic techniques. However, what's important is to determine whether samples that otoliths that are in glycerin as they're usually being kept, whether that is a potential source of DNA for genotyping, and that is work in progress. So far, we have not been successful, but we're working towards developing techniques that hopefully will allow us to do that in the near future. As you've heard in other presentations, an important project within the same research area of reproduction is the full characterization of the annual reproductive cycle. And the main objective of this study is to revise maturity estimates for male and female Pacific halibut. In this study, we have collected samples throughout an entire calendar year in the central Gulf of Alaska, in the Porlock region, a known spawning ground. We're using currently those samples to better understand the reproductive cycle of both males and females, understand the process of gonadal growth, maturation, and spawning as well, with the hopes of providing an accurate staging of reproductive status, to update current maturity date estimates, and to provide information on fecundity and skip spawning, which are lacking for Pacific halibut. One of the first prerequisites for accurately staging maturity is to classify oocyte stages accurately through the use of microscopic techniques. So here we have provided a complete description of the different oocyte stages and how the oocyte diameter varies according to the stage. And here you can see in this graph on the x-axis the diameter of the oocytes in microns, and then on the y-axis the developmental stage of females and how the oocyte sizes increase during the main 3 reproductive phases: primary growth, secondary growth, and finally oocyte maturation. And with this studies, we have determined that Pacific halibut is actually a batch spawner with a group synchronous ovarian developmental pattern. That means that there are several batches of oocytes in development in the Pacific halibut ovary at all times. And importantly, that the Pacific halibut is in fact a species with a determinate fecundity. which means that the annual stock of oocytes are recruited at the beginning of the reproductive season. And the results of this study are already published in the Journal of Fish Biology in collaboration with scientists from the Alaska Pacific Halibut University. One of the first preliminary results that we obtained on the accurate microscopic maturity staging is based on those oocyte stages that we previously described. And here you can see how over time, and on the x-axis you see the months of March until February, and how the developmental stages of females based on those oocyte stages changes from early secondary growth to late secondary growth, to full growth, and finally to spawning in January and February, coinciding with the known spawning time of the species. And now we're actually relating that microscopic maturity staging with the staging that is done currently in our fisheries independent setline survey through visual observation. That's what we call the macroscopic maturity staging. And we're in the process of refining those stages and determine how accurate they are. In fact, as you can see, during the months of June, July, and August, and early September, there's an increasing proportion of fish that are maturing that coincides with the appearance of the full-grown oocytes. One of the studies that we've continued this year is to continue collecting ovarian samples from the same area in Portlock, and we've done that for now 4 consecutive years in order to assess the possible temporal changes in maturity, and the results will be evaluated this coming year. And also, we have started in 2020 a spatial analysis of maturity. That means that within the months of June and July, between July and August, we've actually sampled 5 different areas within the central and southeast portion of the Gulf of Alaska, with the intention to evaluate whether there are any potential differences in maturity across regions. The third research area is growth, and some of the results I've presented before, but the main objective of this research area is to better understand the potential role of growth changes in the historical changes in sizes age, and that is possibly more relevant now given Dr. Stewart's presentation this morning. One of the first things that we decided that was important to start investigating growth is to identify and validate physiological markers for monitoring this trait. So in the process of, or in the framework of a joint grant funded by the North Pacific Research Board and in collaboration with the Alaska Fisheries and Science Center in Newport, we conducted growth manipulation studies with juvenile Pacific halibut, in which we manipulated growth through temperature manipulations or through density manipulations or through even hierarchical dominance and stress. And we evaluated the physiological markers. Some of the results have shown that when we decrease the growth rate or we increase the growth rate of juvenile Pacific halibut, we can identify what proteins and genes are related to those growth changes. And that's precisely what we've done in this study that is almost completed and in the process of being written for publication. And that is the identification of genes and proteins that their expression levels or abundance levels decrease when growth is decreased, or those genes and proteins whose expression levels or abundance levels increase when growth is increased. What's more interesting is that we've been able to identify, in fact, a set of markers that their expression levels or abundance levels change in the same direction of growth, independent of whether it's increased or decreased growth. And those Three markers are promising, putative markers that we can use in the field for monitoring growth patterns. And that's what we're actually doing right now. We're in the process of completing an experiment in collaboration with Alaska Pacific University with captive adult halibut, where we've manipulated growth rates through dietary manipulation. We're actually going to look to see if these markers can tell us fish that are undergoing slow growth versus fish that are undergoing fast growth. So with these tools, we'll able to get a snapshot of the growth pattern of fish in the wild, and that will help us understand better the possible contribution of growth changes and the historical changes in size of age. The fourth research area in our 5-year research plan is discard mortality rates and survival assessment. And for a few years now, and we're almost completed this study, we've conducted an extensive study on using on the directed long-line fishery. One of the first objectives was to establish a relationship between handling practices and injury levels and physiological condition of release-specific halibut and relate this to survival. So we've assessed injuries that are as a result of the different release conditions, whether it's careful shake or ganglion cutting. We've assessed the physiological condition of those fish that are released under the different release conditions. We've looked at condition factor indices, blood stress indicators, energy content, and we've linked that to the capture conditions, time on deck, water temperature, even ambient and fish temperature. And this was a study that was conducted with funding in part from the Saltonstall Kennedy Grant Foundation and in collaboration also with the Alaska Pacific University. This is still work in progress. There's a tremendous amount of relationships to be established, and in particular, we're trying to establish the relationships of individual traits such as physiological stress levels or fitness levels with environmental traits such as time out of water or soak time or temperature difference on the release viability. So this is still work that is in progress. And hopefully within the next year we can provide some final results and establish some best practices for this longline fishery. A second project within the same research area is an estimation of discard mortality rates in the guided recreational fishery. For this, we were able to obtain funding from the National Fish and Wildlife Foundation, and we have several partners, the University of Alaska Fairbanks, again, Alaska Pacific University, and Alaska Charter Association. And in 2019, last year, we started collecting information on hook types and sizes and handling practices by subjecting questionnaires in several ports. And in fact, we conducted a total of 51 dockside interviews in regulatory area 2C, 16 in Sitka, 8 in Juneau, and also in regulatory area 3A, Homer, 12 interviews and 15 in Seward. And the results can be summarized here very briefly. The circle hooks was the predominant gear used in the dockside interviews conducted. Related to hook removal, 54% reversed the hook versus 40% used the twist with the gaff, and a majority of handling procedures involved handling the fish with body and tail supported. 10% only the perculum and 10% only the tail. So these results are actually going to be useful for our next step, which is to conduct a field experiment that had to be postponed this year for next year, for the spring and summer of 2021, to investigate the relationship between gear types and capture conditions and size composition of captured fish, to evaluate injury profiles and physiological stress levels of captured fish, and to assess the mortality of the discarded fish. So we're hopeful that we'll be able to complete this study within next year. And lastly, the fifth area, genetics and genomics, probably one of the highlights was, in fact, the successful completion of the sequencing of the Pacific halibut genome by the IPHC Secretariat and also in collaboration with the French Institute of Agrogenomic Research. This is quite a feat for all the studies that are moving forward relating genetics and genomics. What we can say is that the size of the Pacific halibut genome is approximately 600 million base pairs. It has 24 chromosomes. The sequencing was conducted at a 91x coverage, which means that the entire sequence of the Pacific halibut genome was sequenced 91 times in order to get an accurate description of the composition of the genome. And we determined that the genome contained a little over 27,000 genes. So this genome is available. It's been deposited in the National Center for Biotechnology Information. Is available publicly. And there's actually a genome browser that can be used to view and query chromosome by chromosome the different genomic components of the Pacific halibut genome. The important question is, what is this important for? Well, as I hinted before, it will be essential for all the studies relating genomics and genetics that are coming forward. But specifically, it's essential for all the genomic analysis of population dynamics, including the work that we're going to be conducting on stock structure and spatial connectivity, but also will be important for identifying potential local and or environmental adaptations of Pacific halibut, and to provide a genetic basis for life history traits, such as growth at age, maturity at age, migratory behavior, etc. So this genome will be essentially used in the first large-scale genomics project that we're undertaking, and that is to revise the genetic structure of the Pacific halibut population. In early 2020, we were fortunate enough to complete the collection of genetic samples from spawning groups in the western Aleutians, west and east of Anchiska Pass. And with the addition of previously collected winter samples, now we have an extensive set of genetic samples from spawning groups that have all been collected in the winter. And this samples will be used to determine the genetic structure of the population and establish genetic signatures. So in particularly, we're going to look at, or we're going to revise the genetic structure in IPHC regulatory area 4B, where there was previous evidence for a slight structure. So what we're going to be doing will be low coverage whole genome resequencing. We're going to test approximately 50 individuals for every of this individual winter collection. And with that, we're going to be able to identify millions of single nucleotide polymorphisms that will assist us greatly in conjunction with the use of the genome to determine finally the structure of the Pacific halibut population and establish genetic baselines that are going to be crucial for future studies on movement, distribution, and connectivity. In relation to the larval connectivity studies that I described earlier, one of the next steps will be to analyze the genetic variability among juvenile fish in the Gulf of Alaska and the Bering Sea. We're lucky enough to have genetic samples from fish collected in the NIMS trawl surveys over several years, from 2015 to 2019. And we can actually do comparative genetic studies to identify diversity metrics that are the difference between the Gulf of Alaska and the Bering Sea and estimate admixture proportions. So this will be an exciting complement to that larval connectivity study that I described earlier. And now finally, my last slide is just to highlight the projects that we have received external funding for and that are really interesting platforms for collaborative research. I mentioned the Saltonstall Kennedy NOAA grant that finished in late August of this year, and the work is still ongoing. The grant from the North Pacific Research Board related to size at age and growth patterns and physiological growth indicators. This grant also finished in 2020. And the National Fish and Wildlife Foundation grant that is related to the characterization of discard mortality rates in the recreational fishery that is still valid until mid next year. And that brings the end to my presentation. Thank you.
Thank you very much, Dr. Planas. Are there questions for Dr. Planas on his presentation? Neil, you have a question.
For walking us through a remarkable amount of work across a pretty broad range of topics. I had a couple questions. The first was around migration and the work on migration. And I wondered if you were able to say a little more about where you see that headed in terms of how do you see it eventually feeding into the products that are ultimately used in annual meetings where we are making decisions based on our understanding of stock and how it's going to be distributed and so on. And how much closer do you think we're getting to being able to use some of the findings that you were describing?
Through the chair, thank you, Commissioner Davis, for your comments and your question. That is really one of the highlights of our research program right now, is to try to link some of the work that I was showing on migration with the work that is currently being planned for genetics. I think a combination of different approaches to better understand the topic of migration distribution is key, and the introduction of genetics in that area, I think, is going to be a big step forward in a better understanding of movement and distribution. Obviously, those the stock assessment and management strategy evaluation priorities are all pointing towards migration and population dynamics as being one of the key areas, for several reasons. One, because it involved key biological inputs into stock assessment. But in particular for the MSC process, we've identified that some of these biological inputs are key for improving the parameterization of the operating model. With the combination of approaches, as I indicated, and that are further detailed in this new research plan that is in development, with a combination of larval modeling, combination of otolith work related to microchemistry and isotopic evaluation, and with the use of genetics, I think we're going to be moving in that direction to better understand the structure and the potential distribution and movement. And I think with the establishment of those genetic signatures that I was referring to in one of my last slides, those are going to be key for better understanding movement, at least from adult fish. Those are going to be key to determine what is the level of admixture among the different population groups that we find.
Thank you. My next question was about the work on discard mortality rates. We're investing a fair amount of energy in this. I just, it's seems to me to be a very tricky thing to actually arrive at some reliable estimates of in the absence of at-sea observation in these fisheries. So, attending on vessels, the results seem liable or vulnerable to observation bias. And so I wondered how you have been considering that in the work that your team is doing in trying to arrive at updated estimates for these fish.
Yes, through the chair, thank you, Commissioner Davies, for that comment. I completely agree. I think it's quite a complicated project to undertake, and I think we've actually done significant progress in that area. In the sense that those two projects that we are conducting still, the one on the longline fishery and the newer one on the guided recreational fishery, are the studies that for the first time are experimentally trying to derive discard mortality rates and experimentally derive information on injuries and physiological disturbance of those fish with potential implications on the survivability of those discarded fish. The results that we have so far, at least from the longline recreational fisheries, that the mortalities that we determine experimentally are within the bulk range of those that were estimated through other means, not directly experimentally. So in that sense, it's comforting that the results are within the ballpark of what was expected. The study on the recreational guided fishery is completely new, and given the increasing importance of that fishery in overall in the overall mortality, a study assessing the possible survivability of fish that are discarded, I think any information that we can actually provide, I think it's going to be improved. It's definitely going to improve the handling guidelines and better understanding of the survivability of those fish that are discarded. One thing that I did not mention here, but I did make a mention in some previous presentations, was the work that we linked in the longline DMR work with electronic monitoring. One of our objectives was to try to establish a signature of injuries and potential consequences in terms of survival for the different release mechanisms or release techniques that are used in that fishery, and then see whether electronic monitoring could actually capture at least the release techniques, and then link those release techniques with a particular survival. And even though the work is not completed yet, I think that is possibly a promising area in which, by capturing what are the release techniques that are being used, that different survivabilities can be assigned. So this is, again, is still work in progress, but I think we're making steps forward and in the direction of better understanding the survivability of fish that are discarded in those two fisheries. And I hope this answers.
Thank you, Dr. Planus. Paul, I have one more, but in the interest of time, maybe I will pause there, leave time for others, and if we have time left over, I can come back to it.
All right, thanks, Neil. I see that Peter has a question.
Hi, thanks for that, Dr. Planus. After reading Dr. Stewart and Dr. Hicks's evaluation of directed commercial fishery size limits, it opened up some new thoughts about impossible data gaps in terms of fecundity, maternal effects, possible genetic genetics of slow-growing fish versus fast-growing fish. Under your reproduction analysis, do you see some of those gaps being filled soon?
Through the chair, thank you, Commissioner DeGrief. Yes, those are important questions that we're trying to address in the near future. You mentioned fecundity. Fecundity is one of the aspects of which we know very, very little. And as Dr. Stewart indicated, it's not clear whether there's a relationship with fecundity and size. For instance, in Pacific halibut, that does not mean that there isn't, but we just need to find out experimentally where that's the case. And hopefully in 2021, we can start studies starting to look into how to measure fecundity first, and then how to assess whether there's any change in fecundity with size or not in the species. And related to your question on the genetics of possible genetic changes in terms of important traits such as size and age and maturity and age, we're definitely going to be in the situation to address those issues very soon. I think the genome will be key to basically identify those portions of the genome that are susceptible to those changes, and that will definitely help us understand whether there's any genetic change. But if you were interested in better understanding whether there were some historical changes in growth in relation to the genetics, it's also important to take into consideration that those traits can actually be somewhat plastic, and plastic is a term that is being referred to when a trait is influenced directly by environmental or abiotic or fishery-induced changes. So there may be a combination of both, but as you correctly said, we're going to be in a position to address those issues at a genetic level or genomic level very soon.
Excellent. Thank you. That's all.
All right, thanks very much. Just conscious of the time, it's about 10 to 5, and we're scheduled to finish at 5, and we haven't completed today's agenda. But Dave, I do note when I look at tomorrow's agenda, in addition to, I believe there's no contracting parties update tomorrow, but it also looks like to me that there's some additional flux in the agenda for tomorrow, that we'd still be well positioned to conclude our meeting on time tomorrow, even if we shifted the MSAB presentation to tomorrow. Would that be an accurate description?
Yes, it would. I suspect we're actually even about an hour behind schedule today. I think the agenda is pretty light on tomorrow with content, and I'm confident we'd quite easily make up that hour with the MSC stuff commencing in the morning. So, Chair, the only other thing we have is we have about 4 questions, public questions left.
Would you be of the same opinion if we started Okay, we'll do those for sure before we adjourn. The other question I was going to ask, would you be of the same opinion if we started at 9:30 tomorrow?
I think we'll actually be okay. I think the agenda is actually quite light, and depending on commissioner discussions around a couple of items, I feel confident we could condense some of the breaks if needed to make up that ground. Thank you, Chair.
Okay, thanks, Dave. I'm going to check with my fellow commissioners with the idea of starting tomorrow at 9:30 and moving the MSAB presentation and start with that tomorrow at 9:30. Is there any objection to that?
No.
None here.
Thanks, Bob. I'm going to take silence from...
No objection. This is Richard.
Pardon me? Thank you, Richard.
Sounds good.
Ditto, Chris. Ditto.
All right. So then with that, what we'll do is go back to comments and questions, Dave, and close off on that today, and then we'll start tomorrow at 9:30 with the
Great. Thank you very much, Chair. So we'll bring up the next series of stakeholder public comments and questions on the screen, and we'll run through those for you. If they could just be maximized on the screen so I can read them. Fishing Vessel Owners Guild. It's regarding agenda item 6, so the stock status of halibut and the decisions table, and it's addressed to Dr. Stewart. Dr. Stewart, in 2B this year, in my observations, it seemed that our commercial fishery had far poorer fishing than normal in Dixon Entrance, but the fish appeared in far greater than normal numbers down south in areas like the Cook Bank, Goose Bank area. I'm just wondering how you feel this may affect the projections for areas 2B that were not surveyed this year as part of the IPHC's Fishery Independent Setline Survey. Over to you, Dr. Stewart.
Thank you, Dr. Wilson. This is a good question. We did not have complete coverage in IPHC Regulatory Area 2B. We omitted two portions of that regulatory area. One is the inside waters in the southern areas inside of Vancouver Island, and the other was the outside waters outside of Vancouver Island. Particularly the inside waters have shown almost no biomass in the previous survey where we sampled that area. The outside of Vancouver Island for many years has been at low levels. So although we don't know exactly what was there in a year when we didn't sample, based on historical percentages, only a very small fraction of the overall biomass in IPHC Regulatory Area 2B has been located in that area off the west coast of Vancouver Island. So I would assume that this effect size is relatively small when compared to the overall distribution across all of Regulatory Area 2B.
The next comment, question is from Russell Cameron, and this is regarding agenda item 5, the state of the fishery, and the preliminary statistics presented by Ms. Erickson. Reading through the size limit document, I saw little mention of the potential for high grading because of likely price differential. Recalling past discussions, it always seemed that if high grading became a problem, any gains would be much reduced. Do you see high grading as a potential problem? And secondly, how would you assure high grading did not happen, or if it did happen, how would you know it did or did not happen? So I'll pass to Ms. Erickson and potentially also Dr. Stewart to answer.
Thanks, Dr. Wilson. I can take the first stab at this one. I think we need to consider where we've been leading up to this discussion. We currently have a fishery that is not completely observed in all places, and there is already a price differential in place for small versus large fish. So to the degree that we have concerns over high grading, I think those concerns would be present already in the fishery, and potentially continue under a fishery that did have, or a fishery that did not have a minimum size limit. Given that, I would welcome a comment from agencies and enforcement regarding whether the case with or without the minimum size limit would provide better opportunities or worse opportunities to ensure regulatory compliance.
And so maybe that's something we could also pass to agenda item 9 and make a request for agencies to provide comment on, or if commissioners would like to chime in on that one when we get to the bottom of these questions. So the next question is from Forrest Braden, the Southeast Alaska Guides Organization, again on agenda item 6. The topic is, how is weight per unit effort, all sizes in the setline survey weighted in the current assessment distribution procedure compared to O32 weight per unit effort? Would removing O32 size limit change distribution to regulatory areas compared to status quo? And again, Dr. Stewart.
Thank you, Dr. Wilson. So I did present all 3 indices, numbers per unit effort, weight per unit effort of all sizes, as well as weight per unit effort of O32. Perhaps I could clarify the distinction between the use of those quantities. The numbers per unit effort is used as the index of abundance within the stock assessment for fitting the models and estimating the population dynamics. All sizes weight per unit effort provides our best estimate of the stock distribution in a scientific context with regard to the population dynamics. However, the current interim management procedure is very specific in that it uses just the O32 weight per unit effort. So at this time, the all sizes weight per unit effort does not have a role specifically in the application of that interim management procedure. The second part, I definitely welcome the second part of this question, because the size limit analysis was specifically designed around not changing the distribution among regulatory areas. So we did have to make an assumption about how the yield would be distributed, and we made the assumption in that analysis that the current approach to distributing TCEY among the regulatory areas would remain unchanged. Now, in the absence of a size limit, or even with the size limit, there are certainly other options, and some of those have been evaluated as part of the management strategy evaluation process. But the current results that you see in front of you assume that there would be no change in the distribution to regulatory areas of the coastwide TCEY.
Dr. Stewart. The final question that we have is from Joe Peterson from the Northwest Indian Fish Commission, again related to agenda item 6. Would it be possible for the commissioners to adopt and move forward with changing the commercial minimum size limits in some areas without including in others? In Area 2A, we have a strong history of precise management of both the non-treaty and treaty halibut fisheries. A large component of both of these fisheries is unrestricted in nature and managed by time on the water. In our area, changing the minimum size may have impacts on our ability to manage the fishery that other areas that are more IFQ based would not have. And again, I guess this is more of a management question, but I will also pass to Benny, the Secretary, who might wish to respond.
I'll make an initial response to this. It is certainly in the Commission's purview to adopt or remove a minimum size limit for one or more areas. In fact, in the last iteration of the size limit analysis in 2017, we actually provided some options of what this might look like if it were implemented in just some areas and not in others. I guess I would encourage the consideration and consultation with both enforcement and agency staff to determine how feasible that would be. But from a scientific perspective, there's no impediment to evaluating the size limit on it.
Dr. Stewart. And so at this point, I'll pass back to you, Chair, to see if there are any Commissioner questions or comments on any of those 4 questions. Thank you, Chair.
All right, thanks very much, Dr. Wilson. I'll just see if any commissioners wanted to reply to any of the questions that came forward at this time.
Yeah.
Chris?
Yeah, and I guess I chimed in to say I heard the question about the enforcement. I don't have an answer for it. That's something we can look into. Maybe provide some type of answer, but I don't have one now.
Okay, thanks, Chris. We may have want to come back to these tomorrow, Dave, but for now I'm going to suggest that we adjourn. If there's nothing else, any comments from any commissioners before we adjourn? And then we'll start tomorrow at 9:30.
No comment
Okay.
other than good meeting.
All right, thanks everyone. We'll see you tomorrow at 9:30.